Hi, how's it going? Part 3 of building a card sorting robot. We've got this much work done. We've got this. Oh, wait, you can't see that. Haha. Well, that's okay. You saw it in the thumbnail. We've got the doodad. We've got the thingy. Here, wait. Hold on. Let me figure it out. Boom. No. Boom. No. Boom. Yes. There we go. All right, you don't need to see Firefox, but this is what we've got done so far. We've got a single bin. We've got our grabber, and that's it. However, that is more than we, well, that's not more than we need to do, but that is, we just need to work on it further. I've got a few things to do. I've got them written up here in my notepad, and I will write them out into Paint because it is filler and it makes me look cooler and more professional. Anyway, the first thing we need to do for our grabber, first thing we're doing is fixing the grabber. So you can write grabber. All right, first thing we need to do for the grabber is move the mounting hole up. And I will explain that via switching to Fusion 360. All right, so this is what we need to do. You'll see here, these are two mounting holes, right? There's one there and one there. They are too low. We need to move them upwards because otherwise the linear rail extends beyond the bottom of the contraption, and that reduces the amount of space it can move up and down. Also, it means that I can use more of the linear rail because it won't be blocked off by the top of this doodad. So we just need to move those holes up. Next up, let me get my notepad again. Next up, we need to make a limit for the bender. You might be wondering, what is a limit for the bender? So let me give you a little bit of an explanation here. Move a body. So you see, this bender is the bender. This part down here, that's the bender. And what it does is when you contact the card, it goes up. It goes back down because there's a rubber band here, and it'll force it down. The problem is that it'll just keep going down. There's nothing to hold it on. So you pretty much just need to make a little guide and have a screw hole here, and then there'll be somewhere for it to hold on to. So that's okay. That's pretty easy to do. Next up, we need corners on the bender guide. And I'll explain why we need that very, very soon. So this is the bender, right? Right now, the bender is smaller than a card. That's 60 millimeters. A card is about 63 millimeters wide. So I printed out this version of the bender just to see how it works, how well it works rather. And it is like 70% of the way there. There's one problem, however, and it's that the cards can sometimes be like on the outside of the bender. As in, like, they'll be diagonal. So let me draw in Microsoft Paint real quick. So let's say this is the bender rectangle, right? Occasionally, the card will be like this. And that's problematic. You don't want it to be like that, basically. So if you make this bigger, we can have basically, I'll draw it again. Hold on, let me figure out where my paint is here. Okay. Basically, we'll be able to have essentially like this on the edge of the bender, and the card can go like this, and that'll prevent it from moving, you know, in ways we don't want it to. So well, you will add some corners onto the bender to prevent the cards from rotating. Next up, fix hex. So you see here, this hexagon, it's way too big. I used the diameter as the radius. So it's the complete wrong size, so we can fix that. That should be pretty simple. Next up, lock the suction cup rotation. Okay, why are we locking up the suction cup rotation? It's because the way the suction cup is mounted is here's how it goes. So it has this rod through the middle. That's where the air channel is. And then here's the suction cup. Then here there's a little plate. And then on top of that plate there's a spring. And then on top of that spring is another larger section. This section is where the thing actually gets mounted onto the printer. I mean, not the printer, the robot. But what that means is, and then on top of here there's an end cap. But what that means is that this can freely rotate. And that's bad because it goes back to this problem, right? This is partially a contributor to why it does this. And we don't want to do that because that's generally because the corners will rub against the side of the bin. If you see this bin here, the card corners will rub on the side. And that's something I figured out yesterday after I printed out this bin for the first time. However, I have a solution for that and we'll get to that in a little bit. Anyway, that's another thing we should do. One handy way to fix that though is that here it's a hexagon, so we can just lock it like that. Next up, let me get my notepad again. Tubing channel. So you'll see here that there's nowhere for the tube to go. It just floats. Now that's fine technically, but like I think it would be better to have like a little channel for the tube to be like in place instead of just flopping around wildly. Because the vacuum tubing just goes here and then it just goes anywhere, right? And that's not optimal. That's suboptimal. Next up, we need a stiffer claw. You'll see here that the only thing keeping this claw from just rotating, from bending out, is this little 5mm thick section. So what I'm thinking is I could just add another like bar here, for example, and that'll fix it. Or make this part thicker, or add a triangle or something. Just anything really. It's not that big of a deal. In a way, it helps it like move up and down because it's loose, but like, you know, it's always a good idea to have things more rigid, we'll say. Next up, I have wider and goes around the card, around in underline. However, that's the exact same thing as corners on bender to guide cards to the center, so I'm not gonna write it. But basically, yeah, if I make it bigger than a card, then I can have the card be guided to the center as it's pressed down, instead of just like the card might being bad. And then this will also prevent it from rubbing against the wall, because I know the grabber itself is larger than the card, which will then prevent it from, you know, rubbing on the wall, which is what we do not want, because that's bad. Next up, badge holder. I don't know if you remember this, but we are using one of these. Hold Hold on, let me get an image of a badge holder. We are using one of these as our method of retraction. Oh, well, not retraction, but basically this is how we offset the weight of the linear rail that we're moving up and down, because a linear rail is heavy and you're not supposed to be moving it up and down, but I'm doing that anyway because it's easier. So we need to move the linear rail up and down, and a single stepper motor is not going to be a big fan of doing that. But by adding this badge holder, we can use this as a spring, and since it like is a very consistent strength. I don't remember what exactly Hooke's law is, but I was yapping about Hooke's law without actually knowing what it is. Let's Google that real. Hooke's law. Okay, we need a spring that does not follow Hooke's law. It needs to not scale. So we need a non-Hooke's law spring. And this is close enough. This does the job well enough. So we're going to use one of these. Okay. So that should be it for the grabber. Next up, we need to revamp the bin. There's a couple of issues with this bin. It's just too small. The cards are very close to the edge, which, I mean, I should have seen that coming. I only left like 2 millimeters of space on the side, which definitely is my fault. So we're gonna redesign this bin and make these walls thinner to allow more space around the cards, because then we can have the grabber bigger, and the grabber can be the size of a card plus a millimeter or two. And then that will be able to pick up the card while guaranteeing that it does not scratch the side of this bin. Because that's better for, you know, keeping your cards not damaged. So yeah, we'll do that. That's pretty simple. So, thinner walls. I'm making this way too big. No. There we go. You're wondering why I write so badly? It's because I'm using my mouse. That's just how it is sometimes. Use the mouse. Then I also need to reduce the rub, but that also goes with this. And then I need to figure out how to have the, I wrote slats. I don't know what that means. Slats not touch inner wall? What is a slat? Oh, I remember. You see these things that I added to keep the light out but the air through? Those can't touch the inner wall, because when it's 3D printed, there's a whole bunch of artifacts here where they mate with the inner flat wall. And those rub against the card and make it go click, 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 and it's really bad for the card, because that's where you get most damage from. So that is what we will. So we can either remove slats or make the slats better. Slats. Okay. So that's our to-do for today. And then if we get all that done, then we can do camera mount. And the boring bin. That's not how you... So, yeah. What else? Is there anything else we can get done today? Oh yeah, we can also do motion if we have enough time. So how about we start? Work on the grabber. I'm gonna start on the grabber. Our first task is gonna be to, how about we just make, we're gonna design a full new one. Hello, Citus. I hope I'm saying your name right. Keep it up. I have to keep it up. It's my graduation project. It's due in December. If I don't keep it up, I'm not gonna pass. All right, how about we're gonna make a full new grabber. Just because this one has too many of the old design flaws. It's too blocky, I think, is a real big issue. It's just not easy to move some of these parts. Remember, I didn't design this parametrically because it just needs to be done quick and dirty. And so, quick and dirty it was. Yes, thanks for the encouragement. Does help. Oh, you can rearrange tabs in this application. That's cool. All right, let me get back to my good mouse. The other mouse has a high refresh rate. This one has a slow refresh rate, but it is more comfortable. I use this one for when I do work. The other one is for just drawing, or not drawing, but writing on Microsoft Paint. Anyway, where was I? All right, there we go. I can. Here. All right. So, our new grabber needs to be bigger than the Pokemon card. So how big is the Pokemon card? If I remember correctly, it's 88 by 63. Yeah, 88. By 63. There we go. Nah, I'm not wasting my time. I already wasted enough time, so the microseconds I spend talking to you or thinking about what I'm gonna say towards you don't really change anything. So we're gonna go 90 by 65 for our grabber. I mean, this is not the grabber, but the bender. Bender, like from Futurama. Haven't seen Futurama, I should watch it. Anyway, our actual card will be sitting in the section. Do we make it even larger than this? 65 by 90. That gives us 2 millimeters on this side. Now, the question is, how do I... Okay, I think I've got it. Let me think. Because I need a way to make the bender sort of like gently move the card into position. So I need a way for it to do that like symmetrically. Okay, I've got it. So we're gonna have about 2 millimeters. Okay, I know what we're gonna do. Okay, so we are gonna get the exact dimensions of the card, which let's just create a center rectangle. Here, and we can put down the exact card dimensions into this. So 88 by 63. Oh, that's just one. Oh, thanks for the subscription and the like, Citus. I do hope I got someone yesterday who was fairly familiar with engineering, and that was pretty helpful. But you know, it's okay. I'm here for the vibes, really. Really, streaming here is just an excuse to actually get the project done. So I'll see you later. Okay, what was it that I was doing? Rectangle, right. Okay, so around this rectangle, this side, I think I will make this be so cool. I don't know. I'm just doing what I've been doing. It's, I don't know. It's just what I do for fun, really. And then I had an excuse to make it my graduation project, so that's why I'm doing this. how big is 1 millimeter? 1 millimeter is really small. All right, we're gonna make this be more than 1 millimeter, I think. So we actually need this rectangle to be maybe like 67 by 92. I mean, you're always welcome to hang out however often you like. I'm not like picky about any of that, of course. The way I talk is really funny. My brother, so I'm in college, right? So I meet my brother maybe once every 6 months or so, because I'm in a different country. And so when I met him last summer, he said I talked like a robot. It's really funny. How big is 2 millimeters? Okay, the real issue here is that I have another bin that's 100 by, it's 100 by 9, no, it's 100 by like 74 or something, and it has to be within that rectangle. It's this. So however big this thing is, it's 75 by 100, and so I need to keep this within like that area -5, so that each wall can be 2.5 millimeters. And then I need a little bit of like extra space to move it. So I think I'm gonna stick with the 67 by 92 for now. And then we also only need this for maybe this much on the outside edges. I believe that's the same length, is it? No, it's not. I can use a sketch dimension for that. That's 10. And then this, actually I'll just use parallel. Where's parallel? I'm very intelligent. Oh, it's gone. Why is parallel gone? Oh, there it is. Okay, parallel. Boom. Over constrained. Oh, it's perpendicular there. Well, that's fine too, right? Anyway. Line. We'll just place it wherever, it doesn't really matter. That's perpendicular, and then I need a sketch dimension. We'll make this be 10 as well. It's 8.9992, which is not exactly what we want. So let's extrude this. By 5. And then let's do that again here, but down 5. How big is 5? I think 5 is a good number. So I'm hoping that I can basically hug the cards with this. This is not the right way to do this, actually. I just realized. But I think this means we have good guidelines on how to do it. Basically what I should be doing is a shell on this, I think. There we go. 2. And then, is there a way to make it be a... maybe not. Because what I need is like a draft shell. I don't know how to do that. I mean, like there's obviously the dumb ways to do it, but I don't want to do the dumb way. I want to do like a good way. You know what I mean? Like, is this where I use a loft? Or because I can do a loft there. I don't think I want to do a loft, but I could do a loft. I mean, I could use a chamfer. Should I use a chamfer? I don't think so. Okay, well, we've got to think about this a little bit. Here, we're just gonna do it the way I know best. We're just gonna use a So we're gonna go 5 millimeters, and then I believe 2 millimeters was the way we wanted it, but we can go further in this dimension because of the way we're bending the cards. It will like be bent in, and we actually don't necessarily want it to oh, thanks for the subscription. I can't read Chinese. I live in Taiwan, and yet I don't read Chinese. Woo, that's what we're talking about. Why is this not 5 millimeters? It's because it's 2.5 millimeters. I'm very intelligent. Anyway, so the thing is, we're bending in this direction. This is the direction we're bending in. So actually, I don't think I want to do a sketch there. I will make my sketch here instead. And then here I can, because I know this one is just going to be 2 millimeters. And so I can get my triangle basically just perfect. And I think I'm going to make it like just like that. I think that's a good amount. So let's just do it like that. Alright, what did I do wrong there? These need to be coincident. No. It's not working. Why is it being cringe? Alright, let's delete that line and create a new line that goes from there up to there. And this, kids, is why you should do things parametrically. Does it work still? No, it doesn't. Why? Why? Alright, we'll do it from the other face. Surely that'll work, right? I mean, it really doesn't matter. But it does make me a little bit triggered, so I'm going to keep fiddling around until I can get it to work. Okay, why is it getting 21.8 degrees off from over there? I'm simply trying to just get a line that's 90 degrees from that. There we go. Surely that works, right? Yeah, look at that. Wow. Incredible. And now we just do that on the other one too. Is this the idiot stupid way? Yes. Which is why we're not going to do it the idiot stupid way, actually. Oh, I want to redo that. Let's get the extrude. And then let me see the sketch again so that I can extrude it again. Start offset. I would like to pick my offset there. That's not how you do it. Alright, it should go, I think, 10 millimeters. And then the offset should be like 64 or something. And I'll just move it manually. That's not how you move it manually. Alright, let's go with 70. 74. 72. There we go. Cool. Good job, me. A+. So these will keep it in on that side. And then there's something I need to do to make it work on the other side. Yummy soda. I love soda. Yummy, yummy. Anyway, where was I? Okay, where was I? Oh yeah, building the outside edges. I need the outside edges. How do you do an outside edge? I need to remember. I had the idea, and then I was like, oh yeah, actually it doesn't matter because of something, and then I forgot what that something is, and now I need to remember what that something is. So it's because it needs to bend in this direction, right? So it's gonna form basically a U here. Let me get to my paint so I can draw it out. Basically, this is what we're doing right now, and the card is gonna bend like this because this is where the suction cup is. Maybe not that drastic, but you know what I mean. Yeah, like that. We're gonna say it's like that. That's where the suction cup is. and it's got to bend like that. But instead of bending it like that, now we're bending it like this. And so now it's like, how do we build something like this such that when the card gets released, we don't want it to rub on that. That is bad. I'll write that in red just to highlight how bad that is, because that is where you get card damage, and we gotta avoid as much card damage as possible, because we're gonna be picking up cards like 8 times to like it. We're gonna be picking cards exponentially, depending on, okay, maybe it's not exponential, it's log. It's n log n times the number of, where n is the number of cards in the bin, is how many times we're picking up cards, and then you take n log n divided by n. So it's just log n. That's how many times we pick up each and every card. And so we want to avoid damage each time we pick up the card. That's why making this such that it damages cards the least as little as possible is important. And so that's what we are doing here. And so I need to think about, because there's 2 options we have actually. We can either make it like this, where the card actually looks like, all right, let's say we're in a hypothetical situation where we're not bending the cards. We have 2 options. We either have it like that, so that when the card is not being bent, it is within that gap. That'll prevent it from scratching against it, but that'll also make it scratch. Actually, that's just a good solution, but it means that this is like less. No, actually, I think that is the solution. It just means that we have a smaller area for that, but that's okay. All right, you know what? Yeah, we'll do that solution. We figured it out. Good job, me. Okay, I believe if I do 2 millimeters, that is the correct size. So we will just do 2 millimeters. I forgot to do a line there. A line like that. I would like to join. Okay, why Fusion 360 really annoys me sometimes. Why is it like doing that? You know, this is a line on the other line. It should not be separate. It needs to be 2 millimeters. Like that. There we go. Surely this will fix it. Join. Doesn't. Very nice. Fusion 360, what did I do to you? Alright, kids. Design stuff parametrically. Cool, let's just undo all that then. Alright, we're not that far. If we're having this much issues, we're just gonna restart. Alright, let's start from the top. If we're having that many issues, we're just gonna restart. We need a rectangle, and it needs to be 92 by 77, I believe is the size that we were looking for. No, that cannot be right. 60, it was 65 plus 2 plus, no, 6, it was 67 actually. 92, because it's 88, yeah, okay. And then we get another rectangle. I mean, it really doesn't matter where I'm going to place it, because I will just constrain it. So this one needs to be 88 by 65, no, 63. And then I need to make this dimension be 2. And I need to make this dimension be 2. There we go. Okay, and then I might as well add another dimension. This line. 88. I don't know where the point whatever is coming from, but... And then I need another line here. And then I need another line here. We'll just call it like that. And then we're gonna get a sketch dimension here. 10. I don't know why it's like 7.99999. That's probably what's just messing this up. But like it really shouldn't, because it's entirely, see, look, it's all the solid line, which means that it's all parametric now. So I don't know, chat. I don't know. Get this up 5. Actually, I think, let me use my old one as an example. I think we want 1 centimeter here. Yeah, we want 1 centimeter. All right, let's get back to where we were. Create a sketch here. Two. I don't know, it felt like that wasn't parallel, even though it is. 5. All right, let's see if this works. Yay, let's go. Yippee. Now, the problem about this is that it's the exact same dimensions as a Pokemon card. And I feel like that's generally a bad idea, to have your thingy be exact. So we're actually gonna leave 1 millimeter of clearance. So this one's gonna be 1 instead. And I think we're not gonna make this be 5. We're gonna make this be 2.5, because we're gonna get the same angle, it's just smaller. And then I'm gonna do that for the other direction too. So we're gonna extrude this. I don't know how big this is. 67? Wait, 67? Oh yeah, it is 67. Okay. And then we do the exact same thing on the other side. So we're gonna do the secret technique called, we're just gonna mirror everything when we're done with it. Hopefully. All right, we're gonna mirror it, and hopefully it isn't cringe. I would like to mirror this feature along this plane, and boom, it is cringe. See, because this face, for whatever reason, doesn't. So we have to we just have to do it the other way, which is, you know, manually. I don't like doing it manually, but we will do it manually. So we want this to be 2.5, 0.5, 90 degrees. And then we would like a line from here to here. It doesn't really matter, but we want it to be 1. And then we want a dimension here. This one should be 1 millimeter. Then we click finish sketch. Good. It is not cringe this time. Excellent. Okay. Now we just need it in the other direction. So let's create a sketch here. And I'd like a line that goes from here down 2.5, and then it wants to be over by 1, and then that's it, really. So 1 millimeter. That, and then that. Cool. Now, watch it break here. Boom. And join. Oh, it's cool on that side. It's cringe on this side. Why is that? I did the exact same thing on both sides, except I didn't actually. See, that one has the what's it called? There's a line there, so maybe I make a line here on this side too. So we're gonna start here, do that. Surely that fixes it, right? Join. Yay! Okay. Now we just do that. Good. There we go. So this will hold our card in position as our, you know, thingy grabs them. We just need it on this side too. And then it will not scratch the side of the card, because once it's in the right spot and it puts it back down, it'll stay in that spot because of Newton's first law or whatever. So we don't need to worry about the card. We are just making sure that after it's like being put into the bin, it can be taken out of the bin like correctly. That's all we're doing. Also, what we can also do is cut a little notch out of here on like the top or the bottom. And then when we pick up the card or in the bin, so that we make sure we have space on the edge, we can put like a little thingy on the side to make sure that the card doesn't like move out of the area of this, because that's a problem that could arise. So I'll make sure to add one of those as well. So let me just add this. I'll just do the exact same way I did the other side. And surely it will be fine. Why is this one fully like dark line? That doesn't make any sense. Join. Watch this be cringe. Yeah, it's cringe on that side. It's fine on that side. So we're gonna hit cancel. And then we're gonna go back to editing this. And then we're gonna delete this. I don't know what is going on here, but we need a line. So let's get it from there to there. That might be the problem. Okay, let's try that again. Join. Oh yeah, baby. That's what we're talking about. Oh yeah. Great. Next up, I will add that little notch I was talking about. And I will also add the, all right, here's a couple more things we need. We need a fillet on this. The little one. So that when we bend the card, it's not on a sharp edge. These need to be sharp though. And then we also need to create a sketch here to combine these two things again. So let's do that. You can just make this be 5 millimeters, that's fine. There we go, look at that beauty. And then here's another thing we need to do. We're gonna cut that little notch out like I was saying. Now to reduce the impact of this little notch, we're just gonna have it be here and here basically. And then on the bin, we can also have a notch here and here, but since it actually, you know what, we will cut out a notch there. So let's make some notches. I don't know how big to make notches, I just know that I'm going to make notches, right? So let's do that real quick. Let me figure that out. We're gonna take a center rectangle on this thing. That's not a center rectangle, I want a line. We're gonna get a line here, and then we're gonna get a center actually, you know what? I don't need the line. Here's why. Let's get a center rectangle. Just gonna put it roughly in the middle. Now let's see, how big should I make the notch? Let's make it 20 by 20. And then, watch this. I can get a center somewhere here. Midpoint. This midpoint here. And then this midpoint here. No, that's not how it goes. Okay, how do you do that better then? Let's find it. Let's get maybe... I don't actually know how to do this. I want to learn how to do it though, because like I need to you know, learn. I mean, here's what we can do. We can simply... No, you know what? We'll go back to doing what we were doing before. A diagonal. The problem with diagonal is, I think that's the reason why it keeps being cringe. So I think if we just do a midpoint line and then get from the midpoint, then it won't have that issue. Because I think the entire reason why we're having the really, really long decimals is because we're invoking floating point by using like triangles where we need to do like cosines and whatever. And so I think if I just keep it straight and in the, you know, integer plane or whatever, then we don't need to worry about the really annoying decimals. So let's do this 20 by 20. And then let's get some lines. Is this a really bad way of doing it? Yes, but do I care? No. This is the easiest way to do it, and that's why we're here. We're not here to make it good, we're here to make it easy. Because once it's made, then I can make it good. But if it doesn't exist, then there's no point. Alright, so how big of a how long? We should make it be 1 millimeter, I think. 1 millimeter should be good enough. Because that gives the cards themselves 2 millimeters of like being able to be lifted out or whatever. Which I think... No way, it's Cynthium. I recognize that username. How's it going? Alright, we're gonna get a line here. And we're gonna make it be 1 millimeter off. And that's how large our slot will be. 1. It's almost midnight. Well, in Taiwan, it's 2:43 p.m. So, ratio. I gotta stay up late. You mean I gotta wake up early? I do actually wake up early. I just don't start streaming until after I eat lunch. Actually, I'm here to catch the Europeans' morning commutes, but we don't talk about that. Anyway. We need to do exactly what we just did, but on the other direction too. So we'll just do that, and we'll do that. And then I need a sketch dimension 1 millimeter. 1. And then I do that again here. 1. Finish, and then let's cut these out. Boom. Look at that. Wow. Incredible, isn't it? I'm basically what I'm doing, since you just tuned in, I'm making a better version of this. What this does, this picks up the card. Farm? Like, pharmaceuticals? That's fun. Yeah, I mean, you can just leave this as background noise. I'm just gonna be yapping for a while after all. But yeah, I'm making a better version of this. Because this works, but it has several flaws, so... Back. Yeah. How exciting. Pharmaceuticals. I should not have... I need to get back into here anyway, because I need a 40 millimeter circle. For my, whatchamacallit? Yeah, I would not recommend anyone watch this if they're like learning. Stream delay is atrocious. Yeah, it probably is. I think I set it to just be default. No, I think I might have set it low, but still low is not ultra low, which is different. Let's see. Is there... Let's click this button instead. Manage my stream. There it is. I don't think I'm allowed to like change it. Yeah, it's set to low latency and not ultra low latency. Because ultra low latency has like issues while low latency is like fine, but it's just not as optimal, you know? But it's not like I'm like, I don't know. This is fine. It's not like I'm like doing like chat interactions necessarily. I'm just talking, which is like fine. It could also just be ping between Taiwan and because it's taking the local server right here in Taiwan and then it's you know, it has to go from the Taiwan like stream like YouTube server to go all the way to Megua, America, right? So yeah, but that's just how it is sometimes. Anyway, let's get back to doing the thingy. The next up, I'm going to make these side panels. Yeah, well, I make wool, bro. Hey, I was in America like, when was that? Last month. No, wait, it's 2 of them. Not quite. I was back in Seattle like a month ago because I love Seattle. # Seattle fan for life. I don't know. I'm just kidding. But yeah, I need to do these little side thingies. Here, do you want to see something cool? Boom. Oh yeah. This is not actually. Oh, I deleted it. No, I had my This is just me explaining something. I can't. I deleted my my to-do list. Unfortunately, I've got another to-do list here, but it's just in Notepad, which makes it boring. See, it's not like thematic though. I've got Firefox though. Check out Firefox. Oh yeah. This is my 3D printer UI. Wow, you can get a live stream. I can turn on the light. I can't turn on the light. It doesn't work. But anyway, don't worry about it. Let's do this. All right, let me figure out, cause I figured out these railings. Yeah, I can't turn on the light. I think my printer needs to be restarted. It's been like a bit cursed recently, but oh well. Yeah, so I need to figure out exactly. You know, I don't need it to be exact. It can just be rough, and rough is fine. I want to rotate a little bit. It's easier to work from this perspective for some odd reason. Anyway, we're gonna do. Let me get my old one to figure this out. So it was 1 millimeter. No, it's actually 15 millimeters, and then the part that is at an angle is 1 millimeter. So we will do just that. This is 15. Let's just force it to be. No, actually, I force it from this side because it's the less cursed one. 15. And then I do the very same on this side. Doesn't really matter where it's gonna start because that's gonna be wrong, but that's okay. 15. There we go. And then in here, what I do is, let's see, how wide is this? I believe this is 1 millimeter. Oh, or 1 centimeter. Yes, that is 1 centimeter. So I get the center line here. And then I need this to be 5. Actually, is there a better way to do that? Yes, there is. I need a line. So we're gonna make this be 10. And then we're gonna repeat that over here. And then I do another line. This one's gonna be 10. And then, why is it like that? Oh, never mind, that's fine. Then we select midpoint. Wow, ain't that crazy. Oops, I didn't make it 10 long. You like this, the stream overlay? That's great. I drew it myself, in case you couldn't tell. That's all right. Anyway, there we go. It's fully constrained. Wonderful. And then this needs to be 45 degrees. And it can be n long, so that's cool. This needs to be, you know what? We'll make it be 90 degrees. That's fine. Boom. We do the exact same thing here. See, it got it. It's got it parallel to that, and that's exactly what we want. There we go. And then we can extrude this. This is good. Wow, look at that. And then we just need to, I think I did like 40 or something. 40 is fine. Oh, there is a symmetry tool for this. It's just easier to do that than it is to, well, it's not easier. It's just, it's not like enough for me to decide to use the symmetry. There very much is a tool for symmetry. It's just like, for what I was doing, it wasn't like enough where it's easier to, I mean, it's always easier to use the symmetry tool. It's just, do I care enough to click the symmetry tool, right? And there I did not care enough to click the symmetry tool, which is why I did it manually. But yeah, there very much is a symmetry. See, there's a mirror. But anyway, go back to here for inspiration. I believe this distance between this face and this face is 15 millimeters. So we will copy that. Hello, Lucas. How's it going? Okay, so we will create another sketch. We will take this exact same profile and we will simply, I don't need another sketch actually. Wait, do I even need it to be there? No. Don't, do I? I think I can just extrude from this profile and it doesn't, I don't need the sketch basically. Let's just extrude this. Start offset 15 millimeters. And then let's make it be 5 millimeters thick. And then we're gonna create a new body instead. How long has this taken me? This, so the entire project, I completely restarted it. I completely restarted this project like 5 days ago. And you can see where I'm at right now in the thumbnail. Actually, you can see me restart it in live real time because I streamed it on Tuesday? I don't know. I streamed it like 4 days ago. So if you go to my channel, you can see my stream 4 days ago. That is me completely restarting the project from zero. And so you can see how far I've gotten in this short amount of time. I needed to restart it because my original design was too complicated and it would have been difficult. See, I did not follow the rule of make the first one be bad and easy. I tried to make it good and difficult. And then I, got so lost in like figuring out the minute details that I didn't actually get any work done because I was just trying to figure out solutions to the problems that I forced myself to undertake. So instead, I decided, screw it, we're gonna scrap it and start again. This time I will make it easy and bad so that I can get it to work. Once I get it to work, then I can make it good, right? See, so it makes it make more sense that way. The idea, I was it's really funny actually. I was at my grandparents' place and I don't know why I just thought of the idea of building a card sorting robot, but like my previous graduation project was really boring, right? I had the idea, not a very good idea, but I had the idea of making a food social media platform where like you can post pictures of food. It's like Google Maps reviews, except like social media-fied. That was my original idea. And then you could like see what your friends are eating and then like see what people around you are eating and whatever. And then I was like, this project idea sucks. So nothing got done on that project idea. Until, and then I was like, at my grandparents' place, and I was just like sitting there doing nothing, because at your grandparents' place there's nothing to do except like go on your phone or whatever. It would have helped us in Taiwan, that's right, and that's the entire reason why I thought of making it, is because it would help me myself get lunch. But like I was at my grandparents' place, and since there's nothing to do at your grandparents' place, right, I just like sat there being bored. And being bored is the best way to be creative. And so I was looking on my phone, and I was just thinking, like, hey, what if like okay, several years ago I had searched for card sorting robot. This was like late 2018, 2019. And in 2018, 2019, I looked up card sorting robot. This was me in basically high school. I looked up card sorting robot because I'm like, surely there's one, right? There is one. It's the Roca sorter. And so I look at the Roca sorter. I'm like, hey, this is really cool. I wonder how much it costs. Check the price tag. It's $20,000. And I'm like, yeah. I don't think I can afford that. Because this was back when I really played Pokemon. I was like a real Pokemon gamer. I was a sweat, right? And when you're a sweat, you have a lot of cards. And so you have to, yeah, I was in the, it's $20,000 for a Roca sorter, yeah. And so I was like, yeah, $20,000. I am not affording that as a lowly freshman in high school. So I gave up on the entire idea. Then, for whatever reason, I don't know why, when I was in my grandparents' apartment, I was like, hey, I wonder how those card sorting robots are going. Surely there's one that's open source by now, right? I Googled card sorting robot. And yes, there are more. Except they're all still $20,000 or like an insane price. There's the Fizzbatch 9000, which is like you pay like $8,000 security deposit and then you lease it for like $400 a month. There's the Roca sorter still, which is $20,000. There's the Magic sorter, which is cheaper. It's only $2,000, but $2,000, and it's not a good machine. It's just fine, and then it breaks all the time. And so I'm like, it's literally just a 3D printer, except instead of printing material, it's a suction cup. And it has a camera on it. It's like, it's really not that complicated of a machine. And so, like, I Googled more. There were no like free open source card sorting robot projects that I could find at the time. And so I'm like, well, what if I just did my own? And so that's what I'm doing right now. Another thing with the card sorting robots is that they all use the same algorithm. And this algorithm is like, I hate to be like egotistic, but it's just not a good algorithm. Actually, I did need a sketch there. I don't need that. I need to go back here so I can create a sketch. So the algorithm that all of these sorting robots use is one where, how big do I need this to be? I actually don't need this middle section to be that big, so I can actually cut it off here. I need to think for a second. You know what? I will cut it off. No, because what I need is for a spot for stuff to be mounted to. But anyway, I can cut it off there for now. Yeah. So the biggest issue with the card sorting robots that I had is one of them is the scanning the card. That part has been solved before. I Googled it because like I was like, well, surely someone's made a free open source like card scanning algorithm. Someone has, so that's okay. That's not too hard. But like the actual process of dividing the cards into the bins is where I have the issue. And it's because the way that the card sorting robots work right now. Oh, hi Joshy, how's it going? Yeah, the card sorting robot is finally getting made. Yeah, so the biggest issue I have with the whatchamacallit? specific for Pokemon cards. Right now, I only have Pokemon cards. So I can only sort it. I can only test it with Pokemon cards. But like in the future, I imagine it can work with Magic, or maybe not Yu-Gi-Oh because it's a different size, but Magic or Lorcana or One Piece or whatever. Also, Yu-Gi-Oh has it's a lot harder to scan the Yu-Gi-Oh cards because there's like different like text for like the same art, which you're actually scanning based on the art and not necessarily the actual text on the card, which I think is really funny. But that's the way, like, basically you run reverse image search on the cards against all of the cards that were ever printed, and then you find the closest one. That's how you do the card scanning. And so since Yu-Gi-Oh cards like are always like the same, not the same, but you know what I mean. It's a lot harder to run reverse image search on a bunch of cards that look the same. So these card sorting robots, they sort them into bins, right? And so my biggest issue with that, I think I can extrude this now. Scan the symbol on the bottom left. I could, except there's a problem again with that, and it's that that symbol moves between generations, right? If you look at a card from like X and Y, it'll be in a different spot. If you look in a card that is like from I don't know, the Sun and Moon, it'll also be in a different spot. If you look at a card from base set, it's in a different spot again. So you can't actually just scan the symbol, because it just doesn't work. Anyway, where was I? Extruding this, but also we'll just make it be 40. That's probably fine. And then a new body. Sure, that's fine. Oh, shoot. I need it offset. Offset by 15. 15. And then I'll make it 40. New body. Where was I? It was something about... Where was I? I got lost. Okay. The bins, right? I was talking about the bins. So the way these card sorting robots work right now, at least, is they look at the card, and then each bin that they have is for a different trait. Like one bin can be A, where like the cards that start with the letter A go into that one, and then the next one is B, C, D, E, F, G, etc. Right? And that's like the easiest way to do it. And so it's basically you're putting the cards into the bins based on, you know, what exactly it is. However, that's not very efficient, because you see the cards, I mean the bins rather, they're different. I mean, not they're different, but it's just that when you have bins set up like that, okay, how much is this? This is 10. When you have bins set up like that, you have to have one bin for every letter of the alphabet, right? That means you need 26 bins to sort alphabetically. And then it's not even alphabetically, it's just set in A, B, C. So then you need to take the A pile, put it back into the robot, and then have it sort the A pile, right? I mean, you can run what is essentially merge sort on that and just do it recursively, but people don't do that. They just have it run back and forth. And then the other thing is that, like, then you can only sort by one thing at once, right? Because then you have to sort it by type and then alphabetically, or you have to sort it alphabetically and then by type, and then it's just bad. And so that's how most sorting is done with the current robots, right? And so hold on, where was I? Right. So if you have 26 bins, no, if you have a total of 30 bins, we'll say that's 10 by 3, or 32 bins, that's like 4 by 8. That's a lot of bins, and a lot of them are being used specifically for receiving the alphabetical letters, right? And that's not very efficient, because then you only have like 7 or 6 bins that can be used as input. One of them has to be used for unscannables, of course, because you can't scan every card. But that means your efficiency on the bins is pretty low. And so I was like, well, surely there's a way where you can make it where you don't need to what? Where was I? This needs to be I think 5 millimeters. Okay. I don't need caps lock on, actually. We're just gonna get let me just finish this real quick. So it's really inefficient, bin efficiency wise. And so I was like, what if there's a way you could sort it where you don't need to actually I should have done it one less. Or what is going on? Okay, we're gonna redo. Oh, I can't redo. Oh well, we'll do 30. We'll do negative 30. Oh, actually we'll do negative 20 then. Where was I? Right. The scanning. So the thing is that when you scan, no, I wasn't at the scanning, I was at the sorting. So like, what if you could, I will get to my point very, very quickly. I will finish this so that I can get back to designing. But basically, the issue is that you're wasting all of the bin space for cards that, for like, Shift Control C. No, because when I undid, it went into the sketch editing, and then since I air quotes edited the sketch, it can't redo it because that extrude was based on the sketch. It's silly, but that's how the software works. But where was I? Right, the bins. The bins are not very efficient. And so, I'll talk really quickly to get this done with. So I was like, what if I could just use 2 of those bins to like sort all of the cards, right? And so you can actually use just 2 of the bins to sort all of the cards. You use quick sort, and you just run quick sort using the bins as, because if you have 2 empty bins, you can guaranteed sort every single card in every single pattern, no matter what you have in your like bins. Because what you do, you first scan all of the cards first to get what cards are where into the machine. And then once you know what cards are where in the machine, you can then sort them separately without needing the to move them, right? You sort them in memory. And then once you have where you want the cards to be in memory, you run quick sort based on the index of that card position in your array that you've already sorted. So you run quick sort on the real card, comparing it to that index in the array from memory, and then you use those 2 bins. Basically, you can use that as above or below the you can use the left one as above the pivot point, and the other one is below the pivot point. Once one bin is full up, then you can use, then you're guaranteed to have another empty bin, because if a bin can hold 100 cards, and if the left bin like gets full, then you're guaranteed to have moved at least 100 cards out from the other bins. And so you'll always have an above bin and a below bin that you can sort these cards into. And so that's why you need to, you don't need to, but that's why you are able to sort all of your cards without actually, you know, using more than 2 bins. The problem is that instead of being efficiency n, you're now efficiency n log n, which is, you know, suboptimal, sure. But like, the idea is that because you can make this sorting robot so much smaller by where was I? Because you can make the robot so much smaller, you can make it so much cheaper too. And if your robot is cheap and big, but not fast, you can just have like 20 robots, and then you get the same, not like real speed, but you get like the same sorting capacity as maybe a robot that's bigger and faster, but $20,000. If I can build mine for 400 maybe, right? That's a pretty massive savings in cost, even if you buy 20 of them. And if you buy 20 of them and you can run them overnight, then hey, that's work being done while you're asleep. And that's better than having to stand next to the robot and constantly be feeding it cards because it keeps, you know, sorting them too quickly and its storage space is not that big, right? And so that's my entire like theory behind why I'm doing it this way. Anyway, let us create the hexagon, which is one of those issues I was mentioning earlier. So where is hexagon? Where is hexagon actually? Oh, it's polygon. I'm a genius. Okay, I need to measure this, but it's in the old grabber, so I need to take it out of the old grabber. I believe I'm wrong, actually. I don't really know. It really is not that complicated if you like are familiar with like quicksort, but you know. This is gonna be a fully open source project, meaning that I will make it free for anybody to do if they want to make their own. Because I think it's extremely cringe that the only solution that exists is paying $20,000 for a robot made by TCG Player, or because this is one of those things where it should be easy enough for basically like hobbyists to make one, because remember, Pokemon is a hobbyist game, and so if you're pricing people out of a tool only for businesses, then are you really in the spirit of a hobbyist game, right? No, I don't think so. And so that's why I'm making it free. I'm not even gonna sell them. I'll just make it free for anyone to build at home if they want to. Sorry, my nose is really itchy. That's why you occasionally hear a very nasally voice, because I'm busy itching my nose at that time. Anyway, how big is this hexagon? This hexagon is... we'll go with, that looks like 11 to 12. No, that's 12. I should buy some calipers. Anyway, that is a 12 circumscribed. See, that's where my issue was last time. I typed in 12 and I didn't think about it. This is my old hexagon. That's not what we want. We actually want 6. Classic radius versus diameter issue. Because you know why I made that issue? The circle tool uses diameter. Inscribed hexagon, or inscribed whatever this is, inscribed polygon, that is radius. So thank you, Fusion 360, for being consistent. Anyway, we want 6. And then we can extrude this in a 5. That'll do it. That will do it. Yeah, and I can always sell a kit. I can definitely sell a kit, that's for sure. And I was thinking, like, I could always, you know, even sell assembled kits. It's just, there's a minor issue with patents. You see, the reason that the Roka sorter and the card bot or whatever can afford to be sold for $20,000 is because they have patents on stuff. If I make my thing open source and I don't sell it, then they can't sue me. But if I make my thing open source and I do sell it, then I have to think about how legal issues work. And so then it becomes a real issue. And then I also need to deal with like shipping and figuring out all that jazz. I mean, that's something I can always do, but remember, I'm in college. So maybe once I graduate college, I'll look further into it. And then what I was thinking would be maybe better was like, there's a local card sorting robot, not local right now because I'm in a different country, obviously, but there's a not local card sorting robot either. There's a local card store near where I live, Tabletop Village. You might have heard of it, might have not heard of it. But that store, you currently pays $400 for the, $400 a month for the, what's it called? The thingamajig, you know, the big one. The Fizzbatch 9000, that's the current big dog on the card sorting robot scene. It's like $400 a month. It's like you might as well pay an employee at that point. So what if I became an employee and built them a real big, real awesome card sorting robot, right? That's a cool job. Of course, I don't know if he'd accept that or not, but alas. I can always show him this one and then he'll be like, whoa, or something. I don't know. Anyway, let's get this this thingy made, because I've just been yapping and not actually designing. So we need a slot for a linear rail. A linear rail slot goes in here, right here, between the thingy and the other thingy, and it is an MGN by 12. Let's get ourselves a rectangle. 2 point will do. All right, I'll see you later, Lucas. We just do 40 by 12. Actually, we want to do 40 by 13 so that we have some wiggle room, as they call it. So let us get this length and this length. Can I not do that? Never mind. All right, let's get back into the sketch. Oh, I'm in the sketch. Okay, very cool. Let's get a line from here and here and here and here, and then let's make them be equal. And then we've got to make it such that this line is parallel with this line. There we go. Streaming on Twitch? I used to stream on Twitch. And then, I don't know, I could just go back to streaming on Twitch. I like YouTube more because my VODs stay online. So that if anyone needs to, because then I have proof I actually worked on the project and didn't just slack off. I mean, I'm kidding, of course, but like, I just wanted to try streaming on YouTube because I've been streaming on Twitch for a while. And I feel like for engineering and design, YouTube is a better place. You can do VODs. I mean, I can always do my VODs. It's that the VODs isn't the issue. I think it's mostly visibility because YouTube has a really good recommendation algorithm. I mean, with the VODs, I can literally just record to my computer and just upload those onto YouTube. It's not a big deal. But like YouTube's recommendations means that yeah, I don't need to worry about it. So let's do -10, I think is a good number. Or let's measure this thing. Yeah, 10's a good number. And then, so remember, one of the things we wanted to do was to fix where the mounting holes were located. So I will make one be here somewhere. Actually, you know what we will do? We will get a midpoint line just so I have a spot for this circle to make sense. So let's see. I guess, let's see. They were 25 millimeters apart. Yeah, exactly 25 millimeters. So I'll do one here. 3.3 maybe. No, we'll just do 3. No, maybe we do 3.3. 3.3 is a good number, we'll say. And then that's 5, 10, 15. It actually doesn't matter because we're just gonna do this. 5. 25. There we go. So let's see, how far is that? That is about 1.3 centimeters. That's not measure. So let's see how far I get this point, or does it have to be? Let's see how far that is from that. 10. Very cool. That's fine then. Wait. Is it 10 from the center, or is it actually 10's not a good number? So maybe we extend this up a little bit more. And then what we can do, we can go into our sketch, move the sketch. Wait. finish the sketch, move the sketch after the extrusion, and then we go back into our sketch. And then this line, this dot, we can make it be coincident with this line at the top, and then it will always follow. It will follow that. And so now, wait, let me double check that these things are 25 apart, because that looks big. It has to be 25, right? Yeah, okay, 25. My nose is always itchy. I need to figure that out, but that's okay. I can just itch it and it fixes the problem. Okay, how do we get to this circle to play nice? This top one will be easy, but that bottom one is kind of like right there, you see? So I can always just slot the, go minus 15 just for now. I can always just make a slot for the nut to go into, which is perfectly fine. We will just do that actually. And well, you know what? We will do this, not 15, but 20. And then we will create a sketch on this. You know what? Actually, I should not do it there. What I should do is do it before this extrusion, and you'll see why right now. Live on television. So we take a line, and I just pick a point which I think is good. So this is at the triangle, whatever that means. What if I did 4? What if I just did 4? You know, what if I just did 4? There we go. That's good. And then we extrude it to here. And then, boom. Wow, look at that. Now it's flat. Ain't that crazy? Now we go here, and then we create ourselves some rectangles, except I can't see it. So we need to do a section analysis here so that I can view it. There we go. Get back to our sketch. And let's get some rectangles. I mean, not rectangles. Let's get some circumscribed polygons. Actually, let me measure one of the nuts. Because I need to make sure that it's the right size. Remember last time I just Googled it? This 5.5, I can't tell. We are gonna Google it. Boom! M3 nut size. Yeah, go away, AI. No one likes you, pal. Alright, so we can use a circumscribed polygon of 6 millimeters. No, I was wrong. An inscribed polygon of 6 millimeters. Oh gosh. How dare I get my terminology incorrect. Actually, we're going to do 3.13 so that we have the tolerance. Or 3.15. You know, let's close it off. Finish the sketch. And then we extrude it like so. Minus 2.5. And then I can unhide the sketch because it hides them. And then I can cut this one out like so. And I can also hide this. I don't need that. But boom. Wow. Look at that. There's our linear rail mounting holes. And this here is where our suction cup goes. It goes there too. So I think here is about where I like finished designing it on the last one and hit the print button, which, you know, it took me a lot longer to get to this point, but I've got my notes for what I need to do. These things. So we've got this we've got this done. We've got this one done. Oh, I don't have this one done. I need to do that. So let me mark the ones that I need to. Okay, I did not need that. Thank you though. Got that one done. Suction cup rotation. I've decided that I don't need to lock the suction cup. No, I do. I really do need to. Do I? No, I don't think I do. The tubing channel I do need to do though. Differ claw, I can always think about that in a little bit. I'll mark it though. That one's done. Oh, I need the badge holder. Okay. Remember that. So let's make a spot for this badge holder of mine. Oh, right. I also need a belt. I need to figure out where the belt goes. Belt for motion. Yeah, mtien is what I was trying to say there. Thank you, keyboard. So I need to figure out where my belt is, because the belt is the part that, you know, moves it up and down. But like, how am I gonna like convince it to play nice? Because like, how's it gonna wrap around the stepper motor and all that is something I need to consider. Because, all right, we're gonna Google some linear belt. Linear rail belt drive images. So these are belt on one side and then belt on the other. But you see the difference between this and mine is that basically I'm taking this stepper motor and putting it onto this platform. It's backwards. It's not air quotes correct, end air quotes. And so I need to figure out how to do it backwards. Which, I mean, yeah. So how do you do it backwards? I can have this belt be static, which would do it, but then at the top of my linear rail, I need another mounting point for this rail, for this belt. Now the question there is, do I have the belt loop around and it just goes back to the bottom and that's where I do all the tightening? Or at the top, do I at the top have a second section where it like locks in? Because I could do that too. So that's another consideration that needs to be made, is how do I do the belt mounting? Or what if I mounted the stepper motor onto this grabber thing and then had the belt just like... Wait, I could do that. I could do that. Could I? Can I? Yeah, I could do that. It's the same thing. No, but then the problem becomes the stepper motor will move, and then I have to figure out like, how do I wire it then? Because then I need to... And also, then the stepper motor is also mass that is attached to this thing, which means that it has to carry itself up. And I don't want to do that, so we won't do that. You know what? We will have... So you might notice that we have screw holes here already. So what if I just incorporated the stepper motor doodad here? Or should I put it on the other side? Considerations. So I can put the belt here, or I can put the belt here. Let me get a piece of belt actually, so I know how big it is. Oh, here it is. I just had it sitting on my table. Very handy me. This is 6mm belt. So that's pretty small. I could put it here. But then I need to think about how am I gonna mount the actual stepper motor mechanism, right? Because let's look at our frame. This is where it's mounting onto. Now I could take this and move it to the top. And that would make, because our linear rail, you'll see it right here, this essentially needs to go here so that it can go up and down. So if I mount it on the top, then it would be easier to have our carriage to the side. But then, like, how far off do I need it to be? Because this could also be on the other side. I could mount it in here instead. And then it's less of a, you know, complicated engineering issue and more of a just a thing I need to do. So let's see how big, because I remember I calculated exactly how deep the entire rail thingy is, and it's 13 millimeters, is from it being on the rail to being out of the, to being the front of it. Yeah, that appears to be, correct from my measurements by hand. So how far is this? Because this is where our 13 millimeters will be. So let's create a sketch here. Stop rotating me. So 13 millimeters off from here is about here. And then let's see how far this is from the side of the bin. So the bin itself is, actually this bin is not even in the right spot. It's forward by like 5 millimeters. But here, this is where our bin is supposed to be located. So I can just create a simple sketch here. Yeah, that's fine. Get a center point rectangle. And let's see. So it's supposed to be 70 by 100. And I believe it brushes right next to that linear rail. Wait, is 70 even right? Oh, it's 75. There we go. Ooh, spinny. All right, finish the sketch, and then we can extrude that sketch just to help us see stuff. Helpful. Thank you. 100. Join, or actually new body. This is just our simple sample bin. Maybe 105 would be accurate, but it doesn't really matter. This is just for visualization purposes. We're not actually doing anything with this bin. But yeah, so the edge of the bin is right there. So let's say we go here and we get this, which I believe is 92 millimeters. So if I make the actual bin be 95 millimeters, that gives us 3 millimeters of wiggle room, which is not a lot of millimeters, we'll say. That is a very small amount of millimeters. So our thing has to be fairly precise, is what I'm trying to say. I mean, am I using precision materials? Yeah, I'm using linear rails. But that's still precision, right? And we need to account for that. So this is 92, and we need 13 millimeters of offset there. I just need to figure out how far off of the linear rail do I need to mount the other linear rail, basically. That's what this is all about. The 92. So how about we get our sketch here? And then we can get our rectangle from the center of the whole thingy, like that. And we'll make it be 100 by 75. So this distance is the space we get. Hold on, let me get back into that sketch so that I can make a little rectangle to see about how big the okay, can we make it be 30, please? Thank you. So this needs to be 13 millimeters, which means that we then get 6 millimeters. Wow, that's not a lot, chat. That is not a lot. We get 6 millimeters to work with. In other words, if we make this in another centimeter, then we get that much more space to work with at the top. And if we flip it around and make it go in from the other side, then that's even more space. I think at the very minimum, we move it in by the centimeter. I think that's like the least we can do. So let's just do that. It's very easy. We just do this, move it in -10. The problem there is that now this mounting section is pretty short. It's like 3 millimeters or something. But that's okay. It's okay. We can deal with that later. Just as long as this doesn't overlap with the that. It's fine. Alright, we don't need these sketches anymore. Those were simply for demonstration purposes. I can also just extrude these a bit further, and then we have more space. The problem is that I also need to tighten a nut that goes there, so I can't extrude it further, you know? Also, apparently, like, it's cringe. We're gonna join this. Now, how cringe is that? That appears to be pretty cringe. Uh-huh. Cool. So where did we make this? Here? No. Here? Yeah. Let's change this from being 4 to maybe like 8. No, we're moving in a full centimeter, so let's make this be 10 actually. There. Let it cook. Yep, that's correct. Alright, this needs to extrude further than 20. Yeah, 23 is a good number, I'd say. Yep, that's where we wanted it to be. Yep. Yep, except this one, I'm gonna only make it be 3. Because that's still enough space to slide the nut in, so that's okay. Alright, what happened there? Alright, we don't need that one either. Cool, there we go. So now that's less of a problem. And we're gonna put the belt over here because otherwise it makes it way too complicated. So this one, we can move this one up however many millimeters as well to make it match this side. Be cooking? No way, a third? That's funny. It's like we got the entire, oh, that's my desktop background. You can tell I'm like flipping around my windows when that pops up. You'll never guess where that's from. That's Pine Lake from near my house. Anyway. Okay. It's not that I'm just now using CAD. I've been using CAD for the last like 7 years, 8 years. It's just I haven't like done anything notable in a long time. So yeah, this is me and Fusion 360. I'm very comfortable with this software, but because I'm comfortable with it, I do things the bad way instead of the good way, which is I yapped about in the description of the video. Anyway, so we need to figure out a place for our belt. The belt needs to lock in around here. Now, if I take my stepper motor, which I've got sitting right over here, I believe. Let's look at that. There it is. Our stepper motor. What's the project? I am building a card sorting robot. The robot to sort trading cards. Yeah, it's in the title. Anyway, I've got a Nemo 42 or Nemo 41. I don't remember what it's called. Nemo, whatever it is. Here, let's check. Nemo 17. So it's 1.7. I've got one of these. Why is it a Nemo 17 after all? Let's figure it out. We can read the design documents. It's because it is a 42. No, it's this is so stupid. It's because it's 42 millimeters by 42 millimeters. Obviously, that's why it's 17. Why is it called a Nemo 17? Mounting hole distances and the size of the body. Yeah, that's helpful. Thank you. Ah, there's a Wikipedia. Oh wait, this is RepRap. Here, let's read the RepRap. What? Where is the 17? Oh, see, it's 1.7 inch by 1.7 inch. Yeah, because inches. Yay, I love inches. Everyone loves inches. Anyway, this is a slightly small Nemo 17, and it is about 35 millimeters deep. Which means that if I go from here to here, that's about 35. So it would fit between that gap. And then on top of that is the belt pulley. So if I put the belt pulley here, I can mount the stepper motor like back here somewhere, and it will work. But like, here's our frame, right? So like, what if I need to make the stepper motor like mount sideways? Because there's two ways to mount it. There's a way to mount it so it's like facing this way, the pole is facing that way, or the pole is facing that way. And so it'll either go up and down, you know, it'll either rotate it like, yeah, there's just two ways of doing it. So I need to figure out which way's better. I'm gonna need, because of the way we're having the linear rail done, I'm gonna need to make the stepper motor like have additional bushings, or not bushings, but like belt, not pulleys, because you're not pulling stuff, but the belt rollers. We're gonna call it a roller. I need a way to have belt rollers on the side of where the stepper motor is, so that the belt can be wrapped around more than 0 degrees of the stepper motor pulley. Idlers is the word I was looking for. Idlers. So I'm gonna need to add idlers, meaning I need to have the belt offset anyway. So, because if you look at this, our linear rail is in the middle and our belt will also be in the middle. So we'll need to mount the stepper motor maybe to the side of the belt. But then, like, should I have it mount this direction, or should I mount this direction? And I need to make that decision now, I guess. Or here's an even better idea, actually. What if we designed the mount for the stepper motor here, and then after that I can figure it out. So we will do that, actually. So this we don't actually want. This is body 11. Bye bye body 11. Also, we can say bye bye to body 12. Okay, let's create ourselves a sketch on this thing. This rectangle, we need it to be MGN 12C. You're kind of lost? Don't worry, I'm also lost. Kidding, of course. Only a little bit. I mean, I'm using the lingo, as they say, which doesn't make it very easy to follow. Yeah, that's very helpful. Exactly. If it works, it works. Where was I? I need an image that's not like 580p. Maybe this one. There it is. Okay. I need... No, that's actually completely useless. Oh wait, no it's not. Okay. I need dimension number H. H is 13, so it's 13 millimeters tall. Then, wait, is this MGNT? No, this is just, wait, it says MGNT. Okay, so this is an MGNT. So I need size L. Unless it's L1. I have one right here in my hands. I can just measure it with my fingers. Yeah, that's some number and some number. That's cool, thank you. 30 some number, so it's probably the 32 and not the 45. So 32.4 by W. 32.4 by 27. Thank you for the very helpfully normally dimensioned rectangle that I need to make. So let's get ourselves just a rectangle. Now I have two options. I can either make it in the exact center or I can make it offset a little bit. I don't know which is better. Because remember, I'm literally just winging this in our project, so I don't actually know which one I should do. We're gonna call it this one good. It's like Nile red. You know how Nile blue like makes his food? And so I thought that was good enough. So I went on to the next step, which was to, I'm just doing that, except it's cat and it's horrible. And I think I have a broken pixel on it. Oh, never mind. It's just the little thingy on the screen. Anyway, where was I? What was my values? It was like 27. No, this one was like 31.4, some silly number like that. Oh gosh, 32.4. Oh, my apologies. And then W is 27. There we go. And we can move it around if we need to. All right, so this needs to extrude 13. New body. So that is our linear rail. We will mount it on the top because it makes it easier. So now, you know what? Actually, to make it agnostic to how big we need it to be, we can just make it really big. We can just make it really long, and then wherever I find is best for the mounting holes is where we can, then mount it. There we go. I'm intelligent. We can make this be 50. That's not helpful at all. 100. And then we will get this to be that. No. All right. Can I move it? I can move it. Very cool. I think that's a good spot for it. Yeah. No, that's literally the worst possible spot for it. That's not even like remotely centered at all. All right, let's get ourselves a line from here to here, and then let me get a midpoint of this dot to here. That's not what I had intended for it to do, Here, let's get a sketch dimension from this to this so that that is locked into place, and then we can get a midpoint from here to here. There we go. Also, we actually know exactly how big it is. This should be 37.5, I think. Because that times 2 was 75? Am I bad at math? Let's get into our Firefox and Google. What was it that I wanted to Google? 75 divided by 2. I am very intelligent. Yeah, okay, this 37.5. 37.5. There we go. Okay, so that's right in the middle of our bin. Just, for hypothetical purposes, we just need a thingy to be about in the right spot for us to, just fiddle around with. Anyway, here we had a sketch So I need to figure out how far off this. No, not that one. This is my graduation project, so it does actually have to get done. I need measurement from that to this. That is 29 millimeters. So 29 minus 13 is the amount of space we have in that one direction. One direction. In that one direction to why did I that's the amount of space we've got to make it work, is 29. So that's like what, 16 millimeters of space for it to work. Haunter, yeah, that's right, Haunter's here. We're getting the gang back together, guys. When are you guys gonna come to when are you guys gonna get, when are you guys gonna come to Taiwan, huh? Next year I'll have graduated by then, assuming I get this project done. Oh, your cousin's from... It's hot? It is hot. Also humid. It's like New Jersey. Anyway, we've got exactly 26 millimeters. No, that's a bin. We get 26 millimeters off of this. So here's what we're gonna do. We're gonna do this 26 millimeters. No, not 26. 16 millimeters. That's not what I wanted to do either. I want an offset plane of 16 millimeters. So this is what we get to work with. And then don't forget that I have to screw the doodad into the thingy. So like, let me see. Who needs sleep? Sleep is for the weak, you know? So I can mount this below the linear rail, which then makes it, you know, less complicated. But then that limits the amount of range that we get. But it might be a good idea to... Oh right, that reminds me. There is actually a consideration I need to make here again. Is that I need to make sure that the linear rail, if I move it all the way to the edge of the linear rail, it goes down all the way. I get about 220 millimeters, and for that 220 millimeters I need it to go all the way down into the bottom of the bin, which means that for this we likely have to move this up even further. The belt? No, the belt is actually the least locked in part here right now. Yeah, the belt is least locked in. Right now we're figuring everything else out so that we can lock in the belt. It's just here, I need to add this to my notes so that I remember that the 220 millimeter motion limit thing, we'll call it that, for rail. I'm not doing a very good job at explaining things, so I mean, it's completely fair that you don't understand it. But basically, we're trying to mount this thing onto a rail. You know what? I can show you in real life. Let me set up my camera so that I can show you in real life. You get a desk reveal, even though I've already revealed yesterday and the day before. Anyway, one moment, please. Desk reveal, that's right. You get the desk reveal. Alright. Okay. Camera. Boom! This should work. it did work. So this, you'll notice the watermark. Anyway, this is basically what I'm remaking right now. It's this exact same thing, except this thing is it's not the right size. And so this is the rail that this is attached to. See, that's a linear rail carriage. This is that rectangle. This is not my dorm. This is just my apartment. I live in my own apartment now. Yeah, that's right. You don't get an apartment reveal yet. You have to wait until 2050 for that. Anyway, we need this. So this is that, in other words. If you see, this is the that looks familiar, right? And then this dude goes in like that. Wow, look at that. And so you're wondering, that's the frame. And so this basically needs to mount to that. That's what we're trying to figure out. How are we gonna do that so that it's in the right spot? Forwards and backwards, right? That is exactly what we're figuring out. And so after I do that, then I need to get this stepper motor to be mounted somewhere so that the belt is not like in a really cringe location. Yeah. So that's what that is. There's a power supply. This is the vacuum pump that we plug into the suction cup, which I lost. Never mind, it's right here. Here's the suction cup. See, and then the suction cup just goes in to the thingy like that. Then here's a bin. So this thing goes into the bin, and then it picks up the card. Yeah, it's moving the cards. To sort them, we move them over and 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 over again. That's how you sort the cards, is you have to first move them. Then once you move them, you can take pictures of them by holding it over this hole. This hole, really inefficient, it's n log n. You move it over this hole, and this hole is where the camera lives. And then you take a picture of it, and then you figure out what card it is, and then you put that into an array, and then you take that array, store it in your memory or whatever. You just take that array, and then you sort the array, and then you take the cards, and then you sort them into their position in the array that you've sorted. Like if you know the Tower of Hanoi problem, it's literally exactly that. Except there's a more efficient way to do it because we don't have the limitation of not being able to put the small ring on the, you're not able to put the large ring on the small ring. I don't know. It's a computer science kind of deal. I mean, if you're wondering what the Tower of Hanoi problem is, it's this. So basically, you see this. You need to move these discs onto another one. Like I can move this here. And then I can move this there, and then I move this here, 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 right? Yeah. So basically we're doing this, but with Pokemon cards. And then instead of it being in order, it's randomized. And then to sort them, we have to put them into the correct method. Wow, what a fun and engaging activity, am I right? Or am I right? Shoot, I actually don't know what to do here. Nope. Oops, can I undo that? No. Oh well. Oops. I am very good at this, as you can tell. There we go, I figured it out. Woo! Look at me, chat. That was wrong. Very good. Good job. Alright, there we go. I got it. Yeah. Yay! Tower of Hanoi speedrun challenge. Did I not solve it there? Oh, whatever. Anyway, where was I? Right. We need to do the thingy. Card sorting robot. I got myself a soda to keep me awake. Lying, I would never lie. So anyway, you saw what I need to do. So let's do it. Let's make that mount for our doodad. So we need this thing. We actually don't need to be perfect about it. We can just like YOLO it, in other words. So let's think about how much motion we get out of this thing. So our bins are 100 millimeters tall, meaning we need to move our grabber at least 100 millimeters and preferably at least 110, because there's a secret mechanism that I need to incorporate that I haven't told you anything about. So I need to like, your AirPods are gonna die. That's crazy. So I need to like, I can get an extra like millimeter or two by doing that, but it might be the case that I make the bins shorter. Of course it's still going. It's only been two hours and 7 minutes. That's barely any time. Yeah, I don't know how the entire, like, you know, summer class got into the group chat, but you know, that's fine. It's fine. Fine by me. It's viewers are good. I like those viewer counts, right? Make sure you go and watch my other videos and super chat and like donate the millions of dollars or whatever. Yes, please. I need the money, please. Click on the other videos, watch the ads, turn off your ad blocker, yeah. Oh, you sent a message into a group chat? That's crazy. What was I doing anyway? Like, I had the concept and then I got distracted yet again. Not getting a single penny. Okay. This is so sad. You can give me money for free. Disable your ad blocker. I'm kidding. I don't need money. It's fine. Don't worry about it. Anyway, I need basically this distance to be a number. Yes, I know. Very intelligent words there, me. It needs to be 100 millimeters. No, it actually doesn't count because I have ads disabled on this live stream, so it doesn't actually give me any money no matter what. Here, let me send an ad. I want to see how you do that so I can figure it out. How do you send an ad? Ad. Give me ad. How do I add? How do I send an ad? How do I get an ad? Can I make an ad? Oh, no, I can't make an ad. This is so sad. All right, how do I get an ad going? Let me edit this so I can enable ads. I'm not going to add the ads. No, don't worry. I'm not cringe. I'm not gonna add ads. Don't worry. I dislike ads just as much as everyone else does. Actually, wait. Hold on. Wait. Hold on, give me one moment. Uno momento, please. Can I get here's what we're gonna do. We're gonna get a paintbrush and we're gonna make this bigger. And then we're gonna make this bigger. And then we're gonna make this bigger. And then we're gonna make this be bright yellow. And then I'm gonna make it then we're gonna make it red. All right. Oh, my green screen. Okay. You gotta click on the add. Who are you doxing? All right, make sure you click on that ad. Okay, let's get back to making a card sorting robot. Where was I? I need to make the mount that goes here. Of course. So, where was our construction? Oh, we are in the construction. All right, so we need a rectangle. Basically, a rectangle for our mounting. Now, the thing is that I need to remember. I need to consider how much range of motion we've got on this linear rail. Because this linear rail has, it's got, how much is that? That is 220 millimeters of motion. And so I need to be able to use those 220 millimeters as effectively as possible. Actually, it might even be less than 2. Let me see. Got a measuring tape right here. No, it's 200, so that's even less. So I need to have this 200. I need to move at least 100 millimeters out of this 200 millimeter rail. Now, about 40 millimeters of that is wasted through the carriage. So I actually only have 160 millimeters of rail. And then after that, I need another like 10 for the secret sauce, and then I only have 150, and it needs to go at least 100. And so I need to figure that out. I need to lock in, right? And so let's figure that out. Yeah. How far is 150 millimeters? So basically, there's two ways that I can solve this issue. I can move my mount here that's attached to this up more, or I can move this mount down more. Those are two valid solutions to this problem, but which one's better? I don't know. And so that's what we need to figure out. So what is better? I mean, no, we're gonna make this mount up, and then I'll adjust this one so that it works, because it's easier to do that. It's not just easier, it's better for the mechanics as well, because this, we want this to have the least amount of like torque and slop. Slop. No, we want this to have the least amount of rotation. No way! I have double digits viewers right now. I never actually intended my my setup. Oh, never mind. It's back down to 7. I never intended my my thingy to be able to have double digits. So once it gets bigger and bigger, we're gonna have a more and more scuffed stream setup, which I think is funny and funnier actually. It's better to have it scuffed than not scuffed. Anyway, where was I? Linear rails, right. So let's do that here. We need a rectangle. Right, we are off. Okay. Oh, that's not the right face. So let's measure this, although I have the measurements in Firefox, except I closed the tab, so I don't have the measurements anymore. But I have it right here. Yes, that is quality right there. Okay, we would like a C. C is 15, and then, yeah, that's very helpful. B is 15. Then I need B. B is 20. So it's a 20 by 15 rectangle. 15 by 20 rectangle. And so to, yeah, I just need a 15. It's not that complicated, is it? No, it's not. 15 by 20. And then I believe it's M3. I can test that literally right now because I have a M3 screw on my desk somewhere. Card sorting as in Pokemon cards. So like, let's say I wanted to sort my Pokemon cards alphabetically so I could find them easier. That is what we're sorting. Look, my desk is not messy, it's just very uniquely organized. It's very different from what is normal or considered normal. Alrighty, this was a number that I don't remember. I'm just kidding, it is messy. It is by normal definition messy. I like how you can see my alt tab. You can see my free V-Bucks down there. You can see Orca Slicer. You can see my Discord chat right there. You can see my my viewer metrics right there. You can see my notepad. You can see my OBS right there. See, that's what's everything's going on right there. Then this is my my doodad. Yeah, I have 9 things open. That's not that many. I have my stream web browser, which is this, and I have my normal web browser. Anyway, let's get back to this. How big is it? 20 by 15. So this should be 20. This should be 15. And then I need some circles. We will do it 3.2. 3.2. 3.2. You know, if I didn't press enter and if I just clicked, it will let me just do it over and over again, but I'm doing the bad way because it's faster to get to my keyboard enter key than it is to my mouse button. So that's a minor suboptimality right there, but whatever, it doesn't really matter. Anyway, this is where we will be mounting our doodad to. So now we get ourselves a rectangle. We can just do another center rectangle, and this will be the like platform it's attached to. So how much of space should we do it? How about we do 30 by 30? That seems like a good value to just have. 30 by 30. And then we get another rectangle here, because that's where we will mount it to the top rail. At the very least, we've got ourselves a mounting doodad. Mount it. This. Actually, you know what? That's a little bit high. How about we move it downwards a little bit? Everything is based off of this. So if I just move that down, then our platform for the screws does not interfere with our block, our linear rail block. Going to bed? All right, I'll see you later, alligator. Then I can extrude this. You're gonna lurk. Wow, I can't believe it. Lurker in real life. That's a good number. That means we have a 1 millimeter gap. Wow, plenty. Also, don't forget, in this, we also have to have another belt. I know, crazy. But here we need another belt for the other direction. Yes, the other direction. So we can deal with that in a little bit, but it's not that big of a deal, I don't think. I'll just have the belt go on the other side because then I don't need to think about it on this side. I mean, lurking is a-okay. I don't really have any like against that. I forgot that. Right. Okay, let us get back to our sketch. And then I would like to extrude this. Let's just do 10, that's a good number. So let me just draw something. This'll help explain it. Bye bye free V-Bucks. Oh gosh. Okay. This will explain it. So here's the pulley on the stepper motor, right? And then here's our belt. We need to have it wrapped around. And then here's an idler. Then, if we want to move a thing left and right, we attach it to like right here on the... Then we can rotate this in a direction, and this will move. That's it. It's pretty simple. But yeah, that's how it works. So anyway, let's get back to whatever it was that I was doing right now. The linear rail, right, of course. The second belt. So I need this one. So I need to move the grabber in two ways. I need to move it this way, left and right, and I need to move it up and down. So it needs to go left and right and then up and down. And so the belt that I was talking about here is for up and down. The one that's for here is for left and right. Yeah. It needs to be left and right and up and down. So, you know. So we can now make our mount for this on the top. It will be a very simple mount. We're just, because it's a C on both, so that means we can just take our same exact dimensions and put it here. So this one should be 30, then this one should be 40, I think. Ooh, no. 39.5. There we go. And then we can also make ourselves our center rectangle along the center here. That's not a center. Center rectangle right here, which I believe is the center. Yes, it is. Very cool. And this one needs to be 15 by 20. And we make our center diameter circles of 3.3. And then we can extrude this up after hiding body 13 by, how about we do 10? Now, I believe that this thing is wider than the MGN 12C. I'm wrong, of course. It's more like 35. So we will make this part wider by some number on both sides. How about we make it wider by 5 on this side and 5 on this side. So now it is 40. And then we can make it squared. This should theoretically be the right size to offset our rail here, such that it will fit perfectly into the bin, which we haven't designed yet. This is the old bin, but this is the wrong size bin. So theoretically, this offset is correct. Now, how about we do the I don't know, what do we do? Also, we're almost at 3,000 subs. Now note that I made most of my subs from Bad Apple on a 3D printer. So, you forgot to sub? That's crazy. SMH, my head. Number 2 chatter isn't subbed? That's crazy. I mean, like, are we even allowed to be like friends anymore? I mean... It doesn't matter. I'm kidding. Move that by 5. What about Bad Apple on a 3D printer, huh? Is that not like the best video ever? It's got 1.4 million views. I mean, like, I am of Bad Apple on a 3D printer fame. That's what I am. I am, quote, the guy who made Bad Apple on a 3D printer. You fell for it? You fell for what? What did you fall for? The trap of Bad Apple? What? But it's not a trap. It's awesome. Okay, let's get ourselves a stepper motor mounted. How do we mount our stepper motor? By mounting the stepper motor mounting mounts. So, to the side or to the top is our question. I think we put it to the side. We'll put it over here to the side, and then, yeah, we mount the stepper motor by mounting on the mount of the stepper motor mount. We're making the mount of the stepper motor by mounting the motor of the mount on the stepper motor to mount the stepper motor to the mount of the mount to that mounts to the stepper motor. Obviously. No one in the chat is qualified to give advice. Well, unfortunately, ratio. I mean, the reason why I say ratio is because in my last streams I had mechanical engineer in my chat. So if, you know, they're lurking, then someone in chat could be qualified. Consider that. Anyway, where was I? Card sorting robot. We need to mount the stepper motor on the stepper motor mount. So how about we mount the stepper motor mount on the side of the mount, the mount. Great sketch. We will make the stepper motor go about here. So, do we center it or do we do it a little bit down? Just mount the thing? Yeah, sure. I just realized I only had talk chat instead of a live chat mounted. I mean, selected in my chat, so I can't actually see all of the chats. Which, you know, that problem's solved now. Yeah, we'll solve that problem. Anyway, let's mount the stepper motor. Gosh, dang it. This is big and small. Let's get our Firefox back so we can search for Tower of Hanoi. No. We need to search for NEMA 17 dimensions. There we go. Rep. So you can tell I'm a 3D printer fan because this is where I go. Rep. Very handy. The 3.1 millimeters in a square. Now, the question of the day becomes, where do I mount said stepper motor mount? Because the stepper motor mount might manipulate where I want to keep the alliteration up, but I'm not good enough at English to do it. Anyway, it depends where the belt is mounted here, or the stepper mounted rec wrap too. I think. Anyway. Or was I? We need to figure out how big a stepper motor is so I can choose where to put the belt. So the stepper motor is big, 42.3. That's 52. That's good. This chat is so cursed, dude. Anyway, it's great that I have a chat that I can talk to though while working on this thing. Because it's a heck of a lot better than just doing it yourself, you know, without any chat. Anyway, where was I? Mounting the stepper motor mounts. So I can mount the stepper motor to the mount that mounts the stepper motor. So the center of this would be there. I pointed at my screen in real life, but you couldn't see it because there's no camera. But it's where that arrow is. That's the midpoint roughly. No, it's cursed because it's actually chatters chatting and not no one nothinging, which is what normally goes on. And that's why it's cursed, because anything is cursed. Okay, maybe it's not that cursed. Fine. What was I doing? I was mounting the stepper motor mount. Okay, let's get this stepper motor mounted. So let's get ourselves a 13 millimeter rectangle. This is where the linear rail will be filling in. So like, we are not able to use that space, but we can use this space, we'll say. So if I remember correctly, it said something along the lines of, actually, wait, hold on. There's a more important measurement that we need. And because of that measurement, it might not actually matter where actually it does matter because the thing is wide. Never mind, I lied. Anyway. It's 20. That's the measurement I was talking. Doesn't actually matter. Wait, 20 does matter. Okay. Yeah, because it is 20, I don't actually need to worry about the whatchamacallit. The linear rail carriage is the word. Because the stick of the stepper motor, we're using layman's terms here, of course. Definitely not because I can't remember the correct term. But the stick of the stepper motor is long enough where I can completely ignore the linear rail carriage when designing the mount for said stepper motor, which is great. Okay, maybe not completely ignore. Actually, no, it's not long enough. I lied, because I forgot that you actually have to screw it in. You can't just have it floating magically above the void. So, sorry, I lied. Alright, now that we're done with lying, let's figure this out. So I do have to worry about the linear rail, but that's okay, because it's in reality not that big of a deal, I don't think. So the real issue is that I need to wrap this belt around this stepper. And so let me get myself my pulleys that I can do that with. It's in the other bit. Okay, they're idlers, that's the word I was looking for. Idlers. Idlers. That's a weird word, isn't it? Ah, here they are. Oh, I just blew them out of my hand. I'm so cool. Like that. Okay, these idlers are big. But they're also small. Isn't it crazy how that works? Big and small at the same time. They are small enough where I believe it does not be a problem. Because let's look here. We've got 50 millimeters from this line to this line. Actually, we have even less of an issue, because remember, we can go up to this line. So, it's really not that big of a deal, actually, I lied. So, that's cool. So how about we just design it, and then print it, and then try it in real life? How's that sound? Sounds good to me. So basically, here's what we need to do. We're gonna have a 1 millimeter offset, definitely not because it lines up with the grid and it's pretty like that, but because it's definitely practical. No, it actually is practical. There's a real reason for that. Anyway, we need a 41 by 41 it was. Where? So we'll do this. Now, just because we don't need to worry about the thing with the linear rail doesn't mean we don't have anything to worry about. We do need to figure out how to mount it such that it is structurally secure. And that's because we don't have that much space between where the linear rail lives and where the stepper motor also lives. Which means we can also go horizontally, which, you know, we can use this space up here and this space down here, which solves some of the issue. The problem is that we also just can't do that much. We can go above and below the stepper motor though, which is fine. So we will do that, I believe. Yeah. So let us get our rectangular center rectangle. Yeah. 31 it was, right? 31, yeah, great. Actually, we're gonna make it 4 because it needs to be plus or minus 1 millimeter, or plus or minus 0.01. It doesn't actually need to be 4. So let's change this to be 3.3. And there's our stepper motor mount. Now, I believe if I look in this direction, the distance from here to here is 20 millimeters. So that means this is exactly where we want our stepper motor like mounting faceplate to be. Let's go -5 for the doodad. And then if you remember, this is the actual area of our wait, is it? It's just 30 by 30. Let's see, is it actually 30 wide? Because if not, then it makes it easier. It is not 30 wide. We're goated, actually. We're goated with the sauce. And that means I can connect it like this. Hold on. Boom. Oh yeah. Now that is what we were talking about, except I'm going to connect it further. Connect it to here. There you go. Then it joins down there too. But anyway, that is where our stepper motor mounts. Okay, now what? Now what? We need to design where our pulleys go. So let me get another sketch onto here. I need the circle for our stepper motor. I completely forgot about that part. And our stepper motor circle is, let's just say it is 24 or some silly number like that. Let's see. What is it? It is 22.0-0.5. I mean 0.05. Cool. So, let's just say that that is 23. That seems a bit big, don't you think? Radius is 22.0. That is accurate. Okay. You can cut that now. And then here's what we need to do. This is now where our pulley pops out. And because of that, we need to have our idlers here as well. So how do we have our idlers here? We put them to the side. So let's do that real quick. So let's figure out how much of an offset we need those idlers to be. So it's 20 millimeters. Oh, dang it. I forgot to account for the fact that we need to be 3 millimeters forward. Now, I think theoretically, it does not matter. Theoretically, we can get away with it. But is it like a cringe way of getting away with it? Yes, it very much is a cringe way of getting away with it. But you know what? It's supposed to be easy and dumb. So let's do it the easy and dumb and cringe way. Meaning, I'm actually just going to completely ignore the problem. It doesn't exist until it becomes a problem. If it never becomes a problem, then it's not a problem. So we're not going to worry about it until it is a problem. So, we are taking shortcuts. We are, yes, taking shortcuts. But don't worry, they're cool shortcuts and not lame shortcuts like the boring ones that were created by the boring company. Anyway, let us get back to this sketch so that I can get myself a line here to there so that I can, I need to see this so that I can increase the strength of this doodad. There we go. Get that good. It's not gonna explode, don't worry, it'll be fine. That's what they all say. But anyway. So this here is where our stepper motor goes. It goes in from this side. So this is a block and it goes in like this. No, don't worry. Don't worry, it'll be fine. Trust me. Don't worry. I'm an engineer. I'm not an engineer. I legally cannot call myself an engineer because I don't have the engineering test or whatever. Also, I'm not in an engineering degree. I'm a computer science student, which is completely unrelated to the field of this. So, I'm definitely the most qualified individual to be working on said project. But alas, you gotta do what you gotta do. So, where was I? Fixing a car, that's something I cannot do. I'm not qualified to fix a car, so don't worry about it. Drunk buddy. Look. Fusion 360 is one of those few skills I have, which might be completely unrelated to, you know, what I do, but it's just something that I do. Polish makes you immune to alcohol. It gives you a +3 alcohol resistance. Maybe not immune, but that's pretty good. Anyway. Where was I? Lazy way, right. Since we are doing it the lazy way, we need to extrude... No. We need to create a sketch here. And then we need to make a rectangle here. This one needs to be 14 by 40 at 1440p. He's technically an engineer. See, we should trade. No, I'm just kidding. I'm technically not an engineer. The computer science part is the yeah, coding the robot. That's the card scanning and the whatever else. Gotta go to sleep. All right, go to sleep. Hunk shoe. The sleeveless stream running on in the background. That's a great idea. How would you force Haunter to go to sleep? I mean, it is basically 2 on the West Coast. Wait, Haunter, it's 5 a.m. for you? That's crazy. Maybe you should go to bed. Gulp. Let's get back to designing this card sorting robot. Yeah, you gotta hunk shua. Card sorting robot. So we need some... So let's get a circle. The diameter of this round thing is... I'm pretty sure it's 8. Yeah, it's 8. 8 millimeters. So that is the pulley part. That is how round the pulley is on the stepper motor. And so what we need is what is essentially secondary pulleys over here, which don't be childish about this. But basically, we need a path for our belt. So it will wrap around. But it wraps around like this. Because that way we get good contact with this stepper motor. And that way it also maintains the same length no matter where we are in the whatchamacallit. Meaning, now we get to figure out exactly where I put this on here. So we've determined that this... Okay, we're making a sketch. So from that line is basically this line. So, what does that mean? That means something. That means something. Okay, how long is this? How long is this to this? Is that 20 millimeters from the center, or is that 20 millimeters from the edge? I don't know. Here's a better way to find it out. Oh, that is 20 millimeters from the center. If we go here, then I can basically just that is where the center of the stepper motor is. Meaning that if we want to have our belt somewhere over here, we'd need to have it offset from this, maybe, I don't know. Alternatively, we can mount our belt here, which is a pretty decent alternative, I'd say. But it doesn't actually work. Wait, it could be better if I do it like this, because I could put it to the side. And then I can have the screws here on this flat surface. You know what? That's what we're gonna do. Yeah, we're gonna do that actually. Are we? I can mount the stepper motor slightly farther off. And then I can have the pulley, the idler here. And then I also have more, because then that does not intersect with the whole dealio here, which is the block that I have to avoid. Meaning it's off to the side even further. So here, let's undo everything. Here, we're back to square one. So we will have this to the side further. So like, we're gonna mount the belt here. Heck, I can even have the mounting over here. Wait, you know what that means though? That means something even cooler, is that I am now allowed to mount the stepper motor in front of where the belt is, meaning I can have the mounting part backwards. Drop your phone. Did you break the glass? Oh, was it just loud? It'll be fine. I mean, you could just say that you just say you didn't know, and that in your sleep you somehow knocked your phone off of the bed stand onto the floor. Just make sure you leave your phone on the floor when you go to bed, so that when they ask you when you wake up, you have the excuse, oh, it must have fallen on the floor while I was asleep. Oh, your light is on and your PC's on? Oh, chat. It was nice knowing you. Anyway, we've got to figure out exactly what it is that we are planning to do here. I think I redo everything. Okay, so Now that we're changing where we're mounting this stepper motor, we also get to change. I mean, we've changed where we're mounting the thingy mobobber. So that means we also get to check. We get to see if we can we have more area for like the strength part to matter. So that's cool. So let's get this stepper motor mounted. Now I just need to internalize this and like post this exact. Okay. Okay, yeah. I got it. All right, let's lock in, chat. Let's lock in. I mean, if it is 5, you should probably go to sleep. Did you know that I wake up at 5 a.m.? I wake up at 5 a.m. now. I know. I'm like a real adult. Ew! Yeah. I wake up at 5 a.m. like a boring old person. Actually, the real reason why I wake up at 5 is because I intend to start streaming earlier, but I always wait until I eat lunch. And then I start my stream. So it doesn't actually change anything ever. See, the point of waking up early is so that, okay, I actually have a very good reason of waking up this early, and I'll explain it. The reason why I wake up early is because I came back from Seattle about 2 weeks ago. And because of the way Seattle's time zone is, waking up early and going to bed late is actually easy. And so because look, I'm not getting anyone's ad revenue. And so the reason why I wake up early is because I'm keeping my jet lag. I'm maintaining my jet lag. No, I'm not blaming it on jet lag. I'm maintaining it purposefully so that when I start my job in 2 days, I can get there on time. Right? Because my job starts at 9, which is like, okay, why are you waking up at 5? Except my commute is an hour and a half. Because it's in Taipei, I'm in Danshui, right? Meaning I have to leave at 7:30 at the very latest. And like, if I wake up at 5, then I can sit in bed for an hour on like Reddit or YubTub or I guess that's it. Usually what I do in the morning. Or checking my emails like an old person. Ah, the commute is long. Yes, that's right. Certified Redditor over here. No, because I have to go to a specific building. It's not like I'm leaving right next to the high-speed rail, right? I'm not high-speed rail. I'm not leaving right next to the like subway station. I have to get to the subway station and then walk for like 10 to 15 minutes. And also, it's good to be early. So I'm going to arrive early, right? So it's like in the middle of downtown Taipei, and I live in like Danshui, right? So it's a horrible commute. So I wake up early so that I can get to my job on time. Like a normal adult. Ew. Disgusting. Ugh. Anyway, that's too much serious talk. Let's get back to yapping about a card sorting robot. Everyone loves card sorting robot. I love card sorting robot. Card sorting robot is my favorite. Hey, at least I don't need to make a subway transfer. I know, right? Imagine being responsible. You! Where was I? Where was I? Where was I? Right, I was figuring out my mount for the stepper motor. Boom. Stepper motor on the real life thing I have for today. What, you remember the greasy restaurant? I remember the greasy restaurant. It was greasy as heck. The greasy restaurant? Yeah, I think it was. I don't ever go to the greasy restaurant ever anymore. Because it's greasy. I don't like the greasy restaurant. I actually took you to the least good places ever. Actually, I was very washed as a tour guide. Anyway, can we get back to the card sorting robots? Let's get back to the card sorting. I've just been sitting here for like an hour and a half. Okay. Haha, guys, let's get back to the card sorting robots. How's that sound? Don't need that. So this is the area we're not allowed to be in. So, let's see here. Center rectangle. No. All right, we need to figure out where are we going to mount our belt. So, I think here it would make, actually, I'm not gonna do the sketch at all. Okay, let's create a sketch on this face. Stop rotating me, dude. Okay. Our belt, we're gonna mount it here. Now you might be like, why? And I'll tell you why. Because better that way. Anyway, our belt will be mounted there. Should I do that now or should I do it later? Actually, it doesn't matter when I do it. I just need to do it. No, it doesn't matter when I do it because of reasons. And the reason is because if I have to extend this to make my linear rail have more like extension, right? Then again, it doesn't seem like I will have to do that. I think it'll be okay. I'm basing it off of the thingy I have in my hands right now in real life, and I don't think I'll have to do that, but I probably should do that. Anyway. Let's get our thingy oriented properly, and let's draw ourselves a belt mount. It will be really simple. It's just a rectangle. Let's get it to be like this. I think that's fine. Now I need to conceptualize this belt in my mind in real. I have two ways of doing it. Easy way and the good way. I think we're gonna do it the lazy way. Alright, let's hide body 3. Actually gonna go hunk shoe, incredible. Do I need it to be that big? It does not need to be 30. Does it need to be 30 millimeters? Interesting, because like 20 is a number. Doesn't need to be 30 though, it's a real question. 30. 30, 30, 30, 30, 30. I feel like my brain is cooked. I'm out of soda, that's what it is. Oh no. Oh no, chat. I'm like Frankie without his cola. in the recycling bin it goes. Anyway, where was I? Belt mount, yes. How do you do a belt mount? And also, where do I mount the belt mount? All right, I need the real life example again, because it makes it so much easier. All right, it does not need to be 30 millimeters. I can get away with, I think, 10. No, that is, okay, so that is 15 millimeters. Let me see body 3 again. Wait, why is this 30 millimeters? Doesn't make any sense. How is it 30 millimeters? Huh. How wide is this thing? Let me cancel that. Whoa. That is 67 millimeters wide. Why are you not going to sleep, bud? Right, I get to call you bud. Okay. 67 is slightly bigger than a car. Good. Why don't you just go to bed? It is 5 a.m. Your sleep schedule is fried? Yeah, that sounds... Okay, I guess 67 is fine. That's fine. Okay, how wide is this section? 80. Is it the same here? No, where did it get the 80 from? 30. It is 30, and that's the same as the thing I have in my real life. Flying in your room. Fly on the wall! Will we undo this? Does not need to be 30, no way ever does it 30. If anything, it only needs to be 20 max off of this object. That's the most it will ever need to be. So we can make this the No, that was the one that was supposed to be. Oops, I clicked it too many times. Okay, it needs to be 21 by 10, I think is fine. And then let's measure how far these two are. 18.5. So let's move it again another 1.5. Yeah, I got the mounts mounting. I'm mounting the mounts right now, if anything. Right. Go. And now, create a sketch here, and we figure out a spot for this belt. Check this out. This is the belt profile. So each thing is 2 millimeters apart. So we will add that here. Now the question becomes, where exactly do we add it here? Do I put it here? Or do I put it here? If you look at it from above, stepper motor will be mounted in here somewhere. And then on the side, I'll need the pulleys. So if you remember my drawing, here's this. This is that stepper motor. So if I mount, so the stepper motor will look like this, right? And this is the center pulley. I need to have screws here in each corner. And then I also need this pulley, I guess, to be here for it to work the best. Because otherwise, it's cringe. So we will mount it more. No, I don't want to actually click. So we'll mount it more towards the inside. And then we want the belt teeth to be on this side of the equation. So we're on a sketch palette. So here's what we're gonna do. We're gonna do something like this. So how large is our belt? This 1.38 minus 0.75. Actually, wait, I've got a better idea. I'll take the belt that I have in real life in my hands and just figure it out from that instead. So, about how many millimeters do I need? About 2.5. We will round that up to 3. I think 3 is a good number. So we need a 3 millimeter sized rectangle. So how about we get that? How many? Okay, we'll start at 5 millimeters off. So that and that. And then you see the secret technique we're going to use to make this easy is we'll have a loop at the bottom. So here we can have a screw, because a screw is easier. Okay, why is it being... Okay, let's not do this one then. Delete that. And we'll get another line from there to there then. And then we'll have ourselves a screw that goes about here, I guess. 3 millimeters. And then we can extrude this in. What here? I'm gonna cancel that and go back into our sketch so that I can make this design less. Need another round, and then we can get this line, delete that line, and then we can make this be the tangent of this. There we go. Now we're doing mathematics. Let's go with 10 millimeters because then it's very variable. There we go. Check that out. So we put a screw through there, and then our belt goes in like that. And then how do we hold the belt on? It's simple. Magic and hopes and prayers and our dream. I'm kidding. We actually, what we need to do is, I did this wrong. I'm kidding, I didn't do it wrong. I'm always correct. I'm kidding again, I did do it wrong. Wait, did I? No, I mean, theoretically, this might just work. Like, I might not have to do anything anyway. But in the event that it doesn't, I will just simply make a screw hole somewhere along here, and I will just put a screw through it, and we will call that a day 3. Don't worry, I jest. It is correct. I'm always right. Boom. There we go. If needed, that will lock the belt in. But we might not even need it. I'm just putting it there as a precaution. So that's where our belt is. Wow, look at that. That crazy. And so the belt will wrap around that and lock in on itself. And there you go. That's belt mount number 1. Right, the belt will lock in. And now we go back to here. I think once we finish this belt mount, we might call it a day. I mean, here, let's see what else do I have on my notes. What else do I need to do? I need a limit for the bender. Don't have that yet, but that'll be very quick. Tubing channel. I don't have that. That isn't important. I need the badge holder. This is done now. What? Oh, yeah, that is not going to be a real problem. Well, I'll leave it there. But I need a badge holder mounting point. I could just put that right here. Now you might be like, what? Why do you need a badge holder mount? And it's for a very, very good reason. You'll see it in just a moment. Let me create the sketch. Should the badge holder be there? No, I don't need the badge holder. No, you see the badge holder is used to offset the weight of the linear rail. That's why it's there. It's to make it easier for the stepper motor. That's all it is. Yeah, the badge holder is there because it is a spring that roughly does not follow Hooke's law. I mean, it might, but it's Hooke's law at a distance where it doesn't actually change, like, significantly enough, for our scale. That is what I was trying to say. But yeah, badge holder will go somewhere here. Anyway. It's not that important. Let's check this to make sure it still fits within. It should. Yeah, that's fine. I actually do want to make this longer. There we go. Okay. I don't know why the purple is selected. I don't need the purple anymore. So it's gone. Bye-bye, purple. Okay. Here, let's just fillet this while I'm here. Whatever. Well, we'll do that. That's fine. Purple? Yeah. I'll deal with the belt holder later. Right now, let's finish the stepper motor mount. And we know where our belt is. It is there. So that is actually in front of the 13 millimeters by about... That's not very helpful, is it? No, it's not. It really is not. Can I have it? Alright, here's a better way of doing this. How long is it? 2 millimeters. So it is actually 11 millimeters off. Meaning once we go back here, so our belt exists within this rectangle. Meaning that for our stepper motor, we will need our circles. I don't know. So it's 8 millimeters in diameter. Every single one of these pulleys is 8 millimeters. So I need to do, I need to think a little bit. Would that be 9 millimeters or 10? Make it like actually correct, because remember the belt is not 0, right? The belt has thickness. So I can't just go with 8. I think 10. We'll try 10, and if 10 does not work, then 10 does not work. But let's go with a center diameter circle over this here. This is probably fine. 8. And then we'll make this be 10. And then let's get a line from here to here, and another line from here to here. And then we will create another circle, 2-point circle. Actually, that is wrong. We need a 3-point circle. But there, 8. Wait, I got it crazy. I'm actually nuts at that. No, that's actually the wrong way of doing the method. We should just create a center diameter circle, put it in a random spot, type 8, and then we do tangent this and this, tangent that, and that is how you're supposed to make that circle. And then we create another circle, and then we write 10. A. Yeah, A is right, bud. Okay, let's do that one more time. 8. Tangent there, tangent here, and then a circle 10 millimeters. Okay, there we go. And then we need a center rectangle here, 31 by 31. And then we actually want to move our circle out until it makes sense. Oops, I don't want to move it up or down though. Left and right is fine. So like, does this make more sense? It's like, then a screw is there and a screw is there. Now, how far is this from here? That's not helpful at all. I did not... How far is this distance? 68.657. Yeah, that's a good number, isn't it? Okay, here's what we're gonna do. I'm gonna press D. And then what D does is lets me do this. Then I can say this is 70, we'll say. And then everything perfectly arranges itself to make it good. Except it doesn't, because this should be 1. And then this should be 2. And then this should be 13. And then I think that's finally like correct. Okay, cool. Yeah. Alright, let's get some screw holes made. So that's 3.3. And then we want another center rectangle. This time we will make this one be 40. Oh. We'll make this center rectangle 42. 42.3, we will make it 43. Because then that is like the boundaries for our stepper motor. Okay. See, isn't this so much fun, guys? Look at how simple and not complicated at all this diagram. Wow. All right, I think we're good for this one, except I'm going to extend our lines here and here like so, so that it is not creepy. Go. Then I press the E button. E. And then I can do this, 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 this. This, 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 this. I want this? I don't remember. That. These go back 5 millimeters. Actually, I do want to grab all of this. Yeah, we're grabbing everything except for the screw. Is there a better way to do this? Yes. Am I too lazy to do a better way? Yes. Actually, the better way is technically easier because I don't have to select every time, but I only have to select it every time once. So, you know? There. Look at that. Stepper motor mount. Sweet. Now we go back into that sketch that we just got rid of. And then we hit escape a bunch of times and it not work. Ooh. Okay. I don't need to be in the sketch. I'm not in the sketch. Cool, great, that's good. I'm not an idiot, TM. Trust me, I know what I am doing. I know what I'm doing. What I tell myself when I go to bed. I know what I'm doing. Alright, how far off does this? 10! Now, how far off is that from... Okay, so that rail, this is the center of the rail. This is not the center of the rail. So this is 10 off of the rail, which is 12, which is 6 actually from the center of this. So let's say I unhid that sketch that I just hid. So the distance from this dot to this line is 15. So 15 from there to there. I don't tell myself that at night. That would be foolish of me. Ha 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 ha. Anyway, we want a line from the midpoint of here to, this is 15. No, I don't need self-affirmations because I know I'm goated with the sauce. Don't need anyone to tell me that. Anyway, these things are about 9 millimeters tall. And so that is, we're gonna say that it is 17 millimeters off is where we want to mount our idlers. And so this is 15, which means we're actually too far in. Cool. Great, good, wonderful, excellent. So that means we need to redo this to make it farther out. That's okay, we can do that. That's not too hard, because check this out. Go back to this, and then go to here, we edit this, and then we take this 11.5 and then we make it 21.5. We don't make it 21.5. We make it 11.5. Watch this, you can do math in this. Plus 5. Wow. Finish. Now, if I redo everything, it should be exactly as I did it. With that. Except for that one hole, but we can fix that hole. Actually, I can move this hole further down. There we go. And yeah, that's that out. Cool. So now it is in a position where it is not cringe to work on it, because if you look at it, now the belt from the center is now triangle 21.5 millimeters, but we're gonna extend that by 1 because this is, we can extend it by 2 even, and it's 23.5. So roughly 23 is how far off from this center point we need to be. So let's say I made a sketch here, and then I was like, hey, I want to get a line from here and move it 23 millimeters. That is where we need our pulley to be. Check that out. Is that crazy? So I can extrude this face to that point. And I just extrude it to the point. Great. Can I extrude it to my point? Yeah, there we go. That is exactly what we need our thingy to be. And then I need to add the screw mounts for our bobbers. But luckily for us, we have ourselves a sketch already right here. And so I just need to, actually, you know what? To make it easier, I just go here. I go here. And then I made yet another circle here. This needs to be 5. So our M5 screws. And then I unselect the mounting holes created. And then this is where our stepper motor goes. This entire section up here, I can attach that better to this, and then this also doesn't need to be so wide, because that part can just attach to up here. And so this can be a lot stronger than it looks right now. But after that, what's next? Because that's not all that I need to do for this. I mean, that might be a good, like, day one kind of deal, where it's like, I'll call that good enough TM for now. But, like, still, there's a couple more things I need to do around this area to make it good. One of those things is the motion. How am I gonna, like, because I have more stepper motors that I need to attach. So how do I do that? I don't know. I need to figure that out. because I need another belt. There's another belt that needs to go this way. So how do I do that belt? I need to consider that thoroughly. And it's also almost dinner time. Yippee! This is the longest stream I've done so far. Emotion. Right, I'm like sadness from inside out. I'm blue abu di abu da. Abu di abu abu di abu da. Abu di abu da abu. I can't keep going because I'll get copyright striked because of how perfect my karaoke. Anyway, where was I? I was making this gantry. They call them the biz. Imagine being in the business and be like, hey, we're gonna call this thing a gantry. And then they're like, okay. And then that's what it's called now. Why did I make that voice? Why did I say it like that? I don't know, but it doesn't really matter. So don't worry about it, fam. Okay, here's what we can do. We can extend that to there. The cringe. Whatever, I actually don't. Doesn't matter. It's not something I care about at this. Okay. You know, maybe you should go to bed. Hey guys, chat, maybe you should go to bed. Chat, maybe you should go to bed. Chat, maybe you should. Anyway, be serious for a second here, guys. Now let me be clear. Here, we need to make this block bigger. So let me create a sketch. No, I need to see that bottom. Or do I need to see? So I need to make this bigger. And then I also need to have the channels for the whatchamacallit. Also, I forgot that I need to make a 23mm gap here for the little add on the whatchamacallit, the promoter, you know how it is. But it's like what, 23 or something? Say 24 because that's a good number and it sounds about right. Actually, you know what? Undo. We're gonna make it over here. I know. Unbelievable. Also, I love how it moves me to like a place that doesn't make any sense at all. Alright, 24. And then we'll extrude it like, let's see, 3mm, because that seems like a good number. There we go. It's for structural stability. That's what it's all about here. We love our structural stability. I can't believe I'm wasting my ad revenue by not running ads, because I love my chat so much that I will not run ads because I think ads are cringe. Right, you should super chat me $5 billion. I can make a goal. I will say poggers in real life. All right, watch this. Boom. Wow. Okay. Thank you for the $5 billion super chat. Yay! Woo! You can super chat me 50 cents and I will get 25 cents. Okay, let us make a sketch. Now let me be clear. We need to sketch this one here for the extension of the thingy-mabobber. So let's make a sketch here on this face. Love how it sends me in the middle of nowhere. But okay. 10 millimeters. Is that good? Oh no, chat, I screwed up. 20. And then where was the other thingy? I had the pulleys on my table. I mean the idlers, the idlers, guys. I have the idlers on my table, and I lost it. Yay! Now that is the quality content you come here for. Never mind, it was hiding behind the stepper motor. We'll call that 20 as well. So I need to go here, and then I need to write another 20. You know, that's slightly problematic. That intersects with that. You don't want that. That's cringe. That is mega cringe, actually. Also, this intersects with that, so it's actually super duper cringe, and it actually will not work. Wait. Is it actually super duper cringe, or am I just like cringing and being bad because I'm over guessing? Alright. It's 18. So let's go with 18 here. And then let's go with 18 here. We might want to incorporate some tolerance here. Yeah. Yeah. All right, you remember that silly, super complicated one? We're back. So this one. This one actually needs to be more like 14. Oh gosh, what moved? Why did it all move up? Can I make this so that's a center point, and then that, so that should be fixed in place. Oh, never mind. Okay, why is this not constrained, huh? Well, anyway, this needs to be 12, or let's go with 14. Okay, and it moved again. Oh, you know what? It's because I need to mark it be perpendicular, wherever that is. This needs to be perpendicular there. Now it's constrained. Look at all those dark circles. That's good. That's good. That's what you want to see. 14. Wow, wasn't that easy, guys? See, look at how simple that is. And then since I need this space to be bigger, I can take this sketch dimension and make it be 80 instead. And there you go. Wow, this is so cool. Ain't that crazy? And then if I click finish sketch, I can resume the timeline, and everything should be exactly the same way it was before. Wow. Incredible. See, it's easy. People who say this stuff is hard are lying to you. It's all big lies. So easy. Why is this hole so big? I'm just kidding, it needed to be big. So what was it that I was doing before I found this issue? The belts. Right. The belt. We're gonna say it's probably fine. And I probably designed it in a way where I don't need to worry about it. We're gonna say that. So yeah, we'll say that. Wow, you just got #1 top fan in my chat. That's crazy. How does that make you feel? Anyway, I need to. This is a screw hole. This 18mm doodad is for. I need to take this 20mm, and then I need to make it perpendicular. Wait, is that what? Huh? So here, I need a line. Anywhere here is fine. And then here is fine. So what it needs to be is perpendicular, or horizontal, I guess. That's good. Tangent to this. And now it's locked. Great. And I do the same thing over here. Horizontal constraint. Tangent. Oh, no. Tangent to this. And then it's locked. There we go. Look at that. Now, don't make any childish jokes. This is a pulley system. Now, you might be thinking of something else because you're like that. Anyway, let's get ourselves a line that goes from that to that, and from that to that. Yeah, that's good enough. So I need to be able to extrude this outer one. Okay. Here's what we're gonna do. We're gonna take this, do that. And we'll do that same thing very much here. And then you need this line to be tangent to this. And then I need this to be coincident to this. There we go, like that. And then I need this one to be consistent like that. Oh, it's already there. And then this needs to be a tangent to that. There we go. And then this actually can't be 18. This needs to be 20. 20 again here. We are right now just making the tracks for the pulley to go through. Because then I can make this one longer. Because that is better. Longer is more gooder, as they say in the industry. In the biz! Alright, let's see here. How big do I need to make it? We're gonna say 10. 10 millimeters. Except I didn't get anything. I mean, I didn't get everything. Alright, I need this side too. Alright, you know what? That looks ugly as heck. And there's a good reason why for it. It's because of this ram section. If I instead go here and I take a line that goes like this, it will be less ugly. There we go, tangent there. Tangent to this. There we go. Then we go back to our extrude, and we do not select these. And we hit OK, and then, wow, look at that. Except I did it wrong again, guys. I need a line here. So we're just gonna make that completely separate, actually. There we go. There we go. Look at that. Incredible. You know what? Since it's already basically square, you know what we were gonna do? We're just gonna make it a rectangle. We're not gonna do this whole tangent business. No. That's not what we're here for. we are going to delete this line by line. I'm gonna delete this line too, and this line. Oh no, guys, we're getting rid of all of the lines. What are we to do? Then I need one here, goes here, it's square, it's tangent to this, and then it's also a line from here to here. Wow, did I actually just like clutch god that? That's crazy, dude. Oh no, I didn't. Need a line here. It doesn't really matter where, because we'll just constrain it afterwards. It needs to be horizontal. Okay, it's already horizontal, and then we need it to be tangent like so. And then we need to do the very same thing over here, except look at that. We can do it all the way over there. I didn't want to add the extra line, but sure. This tangent there. Wow. And then this coincident to this. And there you go. And then we go back to our extrusion, and we can deselect those. Boom. Incredible. Except I did it wrong again. Haha, I get pranked. These. And these. There we go. So now the pulley will wrap around like this. Yeah. I mean, it basically is a Tetris shape. Tetranomino or whatever they're called. Right, I know my lingo. I'm hip with the kids. Right. Beating the unk allegations. Wait, does knowing it's called a tetranomino make me more of an unk? Dude. Yeah, it's just a Tetris piece, guys. Okay. Let's get back to serious talk for a second, guys. Rectangles and squares and squares and rectangles and rectangles and rectangles and squares. Okay. Here's what we need to do. Create a sketch on this. We need a little itty bitty tiny bump so that to work as a washer, basically. We are gonna make this be 0.5 millimeters. Dude, I just realized something. Yeah. I just realized that this piece is extremely cringe to print. Ew! In the biz, that's what we call a no-no moment. Because I have to use support on this piece, and support is always something you want to avoid. So, I have two options. Either I leave it as is and just 3D print it with support, or I redesign the thingy so that it doesn't need support. I might unironically choose to redesign. I mean, this entire piece can just go onto a different part. Why are you all still awake? It's like 3 and then it's 6 for one of you. Am I just that entertaining? Yeah, the pulley goes into the square hole too. Oh, it's 6 p.m. Oh, that's not that bad. Wait, are you in Taiwan time? 'Cause it's 6 p.m. for me. Wait, are you in Taiwan? You want to get dinner? I'm kidding. I jest. Simply jest. Oh, you're in the general area. How boring. All right, we're gonna redo this, Johnson, such that it is not. Here, watch this. It's actually really easy. Check this out. Check this out. We go to this, and then we click New Body. And then we click Boom. And then, wow, look at that. It's a full new piece, and it's 3D printable easily. Wow. Okay. And then what we do, we create yet another sketch. Create line. Actually, we don't even need to create another sketch. We undo that. We can delete. Here, it's actually really easy. We go and we view our sketch that we have, and then we just extrude it again, except with all of the profiles selected. And then we started from the offset of 10 millimeters, and then we will go 5 is a good number, I'd say. Then you do join. And there you go. That. Wow, it's printable now. Yay! Yay! And then our thingies are supported from 2 sides. This part is for the stepper motor. Oh yeah, I also need to do this. Is this printable? Yes, it is really printable, and I will show you. I can prove it to you right now. Check this out. Let's 3D print this. Let's send it to my slicer software, and then let's delete this because we don't need that anymore. And then if I take this, I rotate it. I rotate it like so. Check that out. No supports needed. And it will take 49 minutes and 8 seconds to print. Look at that. No overhangs. So good at this. This is my job. This is not actually my job. I am unemployed. I'm not employed. Unemployed. I teach English. I have my English teaching job, which I start in 2 days. Believe it or not. I get to teach kindergartners. So that'll be interesting, we'll say. I'm not unemployed, but I'm actually very much employed. I teach English, yeah. I don't speak Chinese. No, I don't. But this this place is like one of those places where it's like supposed to be only English, so it's actually a-okay for me. Try to start this print. I don't think I need to do any more modifications to that part. I think this part is actually fine. No, I do need to do stuff to it, but like, you know. How much do I get paid? $1 million. I kid. I get paid 600 NT per hour. That's 1 centimeter. Not bad at all. Am I cooked? Could be. I need to create a sketch here. Then I need these to be. Let me get my number correct. Let me get to my Firefox so I can search for M3 through, wait, M3 through dimension. Hey, 20 USD an hour is very good for Taiwan as well. Like, consider Taiwan prices versus USD prices. Yeah, I know it has a millimeter. I'm looking for the other dimensions. Stupid AI system. 3 millimeters by, we will say that is 6. I think 7 is the number I usually use, so we'll just go with 7. 7. I didn't even type the button there. 7. 7. And then I extrude this -3. Alright, now how much space is that? That's 16 millimeters. That's pretty decent. That's not bad at all. Okay, great. Did it. I messed up. I goofed. I screwed up completely, actually. This is wrong. This profile is incorrect. It shouldn't be that difficult of a solution, but it is incorrect, so I need to fix it. It's in the wrong direction. I need to rotate it 90 degrees. Of course, that changes the measurements for literally everything else, so that's cool, yes. Let's see here. Where did I make that? That was here. Okay. But what does that change though? Here, let me see something real quick. Let me create a sketch here. And let me create a center rectangle. Here. Yeah. As long as the following is true, we're golden. As long as it is not 30. I mean, as long as it is at least 30. And that means we're still good. We just need to do our rectangle in the other direction, which is not that big. How's this one? So we just go back to Control Z. Go back to here. And we change this one to 15. We change the other one to be 20. And then that's it. Oh, what the heck? This one needs to be 15. And this one needs to be 20. There we go. Oh shoot, it moves everything. I need to make this dot fixed. There we go. You're going to DC in 1 hour? Cool. Why don't, at this point, you just stay up and then go to DC and sleep on the whatever it is that you're taking. Here we go. See, look, it's not that big of a deal. Look, it's still fine. Everything is... Alright. Yeah, sleep on, how do you get to, whatever it's called from where you are? I don't even know where you live. Yeah, just sleep on the plane or bus or whatever it is you're taking. Yeah, where are you? The metro. They have that in America. Oh, that's nice. I don't know what that means though. You literally live in DC? Oh, okay. So like you live in like Baltimore or something like that? It's not nice. People get shot. Yeah, people get shot all over in America. It's not that big of a deal. DC isn't nice. Well. Yeah, that's how they keep the property taxes low. Yeah, Daly's kind of nuts. Do you not live there? Okay. Alright, we need another couple of screw locations, and then I think we're pretty much good to go. I don't know, what do we call it for today? I don't think we call it. What is this box? It's on body 14. Oh, okay. For another hour, should I order Uber Eats? If you super chat me my lunch, I mean my dinner, that would be crazy, but yeah, you should super chat me my lunch, I mean dinner. At least super chat me the delivery fee. I don't know. Here, let me go to Uber Eats and see what I can order. What do I want to eat? Send it to me on Ko-Fi. I got a Ko-Fi link. They take 0% there. Ko-Fi. If you click my YouTube profile, it's in there. You know what? I'm not that hungry. Yeah, Ko-Fi is basically just Zelle. It's just like a different way of doing it. It actually just goes directly to my PayPal. But you know, we don't need to, I'll just eat afterwards. I'll eat after my stream, it's fine. Don't worry about it. Let's see here. No snacks. Chat, no snacks. Womp womp. Okay, let's. Yeah, it'll just be like 7 instead of 6. It doesn't really matter that much. Yeah, no mukbang. Yeah, you get the no camera mukbang. Probably crazy. Okay, where are all these bodies anyway? Oh, this body I don't need. Hello, Dante Kavi. How's it going? What do I need? I don't need anything. Don't send me money. No, stop. You do not need to send me money. I'm not gonna order Uber Eats, dude. It's okay. No. I'll just go to. No, stop. I'm not ordering Uber Eats. Yeah, it's a scam, exactly. So you should not send me money to order Uber Eats because I will not order Uber Eats. I will just pocket that fee and buy like some Yanshuji or something. Popcorn chicken goes crazy at. Anyway, what was I doing? I'm just circling around this object that I created. This is my stepper motor mount. Now what about the stepper motor mount? It makes the mount stepper motor. Okay, how do we do the belt? So I need to figure out how I'm gonna mount. So I have a stepper motor mount already made for me because they came with the stepper motors when I ordered them online. Meaning I don't need to make the other stepper motor mounts. However, the question then becomes, cool, where do I mount these stepper motor mounts? Like, I could mount them to the side. I can mount them diagonally. I don't know. 18 or older. You need to be 18 or older to do what? To send money on Ko-Fi? You don't need to send me money on Ko-Fi. Don't do it. Alright, I need to take this stepper motor mount apart so that I can get to it. Well, it's simple. Just don't send me money then. You need to be 18 or older to send me money. Or you can send me a super chat. No. Yeah, Ko-Fi is basically just a way for PayPal to go directly to others. But, like, you know. Don't. Yeah, that's right. Do not super chat me. I don't think. Wait, let me Google this actually. How much does super chat cost? Super chat YouTube cut. It's only 30%. It's not that bad. Wait, hold on. Reddit. Oh, it is 50. Cool. Oh, if you do it on an iPhone, then it costs less. If it's on an iPhone, then the 30% that is stolen by Apple gets passed on to me. Right. What M3 size is this? M3 by 8. Yeah. Screwdriver ASMR. Oh yeah, that's an M3 by 8, I think. No wait, could that be M3 by? No, that's M3 by 8. Oh wait, that's definitely M3 by 8. Oh yeah, 100%. Look, don't send me money. I do not need the money. Okay, there's one screw. Yeah, re a semicolon is actually the most agreeable opinion. Alright, so the stepper motor mount can mount on the side of this card sorting robot, and it is this side right here. It can mount there. I was attaching my stepper motor to the stepper motor mount, obviously. What else could I be doing? Duh. So the problem about, well, there's not really a problem. I guess it's fine. Yeah, it is fine. Okay. Cool. All right. Here's what we're gonna do. We are going to do the other stepper motor belt mount here. That's what we're doing. Okay, this one should be easy. It's just, so they need to be about, how big is this? I don't know, 8 millimeters apart, and it'll say like 3 millimeters wide and on each direction. So we'll call that 6 millimeters apart, 3 millimeters up and down. For simplicity's sake. I have words. I can use diction. Anyway, so we will try to avoid this screw section right there via going above, and I do not want to see body 10 for the rest of my life. Thank you, goodbye. I will put it here, and I'll put it here. Actually, you know what? We're not going to sketch it there. We're actually going to sketch it on this face. So, here's what we're doing. We're going to get a rectangle. We're going to get a set of rectangle, and we're going to put it... yeah, we'll put it here. Actually, this is fine. That's fine. Then this needs to be 6. You're actually gonna go to sleep? That's a good idea, pal. That's a good idea. Then I need another one of those. Make it 13 probably. Start it here, and we can cut in on this side. Go with 10. Yeah, that looks fine to me. So our belts will go through this channel. Now I need to make a spot for the belt to wrap around so that it can be, you know, stuck in place. So that's what we're gonna do right now. So this is in the middle of that and that. And so we're gonna create a circle. 2 tangent circle, there and there. No, we need a 3 tangent circle. Actually, you know what? We need a rectangle a center rectangle centered here. We're gonna have 7.492. Why is it such a silly number? Well, whatever. We will leave it be a silly number. It's fine. Wait, that makes me curious. What is the length between this? 0.00000. It's 0.008. Whatever. Okay, where were we? We were in this sketch. We were doing the thingy. Okay. So let's get our center rectangle here. And then we will make it be whatever number, I don't really care. And then this one needs to be 2 millimeters. And then we can go and get our circle, 3 tangent circle, 1 tangent here, 1 tangent here, 1 tangent here. But we need it to be flipped. So let's do that again. 3 tangent circle, except we will select this one, then this one, and then, okay, that's not very helpful, is it? No. And oh, okay, very cool, chat, very cool. Let's get ourselves a circle again. Circle. 3 tangent circle. Wait, can I do Control plus slash? Oh, there we go. That's completely useless. Thank you, Fusion 360. All right. Circle. 3 tangent circle. Oh, wait. What happens if I select this one, then I select this one, then it's still backwards, guys. It's still backwards. All right, here's what we're going to do. We're going to create a new line that's from there to there. And then when we create our 3 tangent circle, we will use the new line. Chat, is this real? Cool. Thank you, Fusion 360. Okay, great. Let's do that again, but on the other side instead. Yes, because that's what I intended to do. Okay, here's what we're gonna do instead. We are going to draw just a circle. I did not want it to be like that. We're just gonna draw a circle, and then we're gonna tangent there, and tangent there. Wow, wasn't that great? Let's do the same thing on the other side. So that works. I don't need this line, but I need to make my tangent again, because there we go. So that's cool. We got that. This is where our loop will be. 3 millimeters. That's for our M3 screw. We're just gonna do it. We're just gonna use M3 as our oops. You know what? We don't actually need it to be that big. We can make it smaller. So how about we undo everything we just did? And then we get a line from there to there. And then we'll get a sketch dimension from there to there. So that I have, no. 5. Because this way, I can control it. Now we create a circle, and we get some tangent constraints. Now that we have our tangent constraints, now we can add our center diameter circle of 3 millimeters for our M3 screws. And then we can add ourselves... I did it wrong again. So let's just get to undoing again. I don't actually want it to be based off of this line. I want it to be based off of this line. So we're gonna go back to undoing everything. So Get our midpoint here again. No, can I get it off this line? No, I can't. Of course I can't. So here's what we're gonna do instead. We are gonna undo that too. And we're gonna create our sketch off of this plane. And of course it loves to. No way, Ash no there, thanks for the sub. And then I need to go here, and then I do the thingy I was just doing several times in a row. Here's our midpoint. We will just bring it down here. Doesn't really matter, because this is simply a line we're going to use for measurement. Not actually going to be used for anything. But here's what we do. We take some... Wait. I can take an offset of this line. And then we do both sides. And then we do maybe like... Wait, symmetric is better. So let's do 2 millimeters. No, we're gonna do 1 millimeter. So then it's 2 millimeters. If you're wondering what the ding-a-ling-a-ling-a-ling is in the background, that is the garbage truck, because I'm in Taiwan and that's how they work here. Yeah, what a horrible, horrible location. Am I right? Or am I right? I kid. 2 tangent circle. Tangent there. Now how big do we want it? M3, the socket head is 6, so we're gonna do it by 6. That's pretty big. You want it to be by 6? It has to be by 6. Your neighbor burns the trash? Yeah, that's great. Good for the air and etc. too. That's wonderful. Alright, we're gonna go with 6. Wait, that's radius 6. We need radius of 3 actually. Radius of 3. That looks a heck of a lot more normal. 3.5. 3.25 actually. There we go. Wait, I just realized something. Okay, I need to think, because what this socket head, what this is doing is basically, I need to make sure that it goes all the way in, but the length of this is 10 millimeters, meaning that since my belt is 3 millimeters, I actually only have 2 millimeters of like leeway basically, or no, 4 millimeters, but because the socket head is 3, then I only have 1 millimeter of leeway. And that's, wait, it's fine because this is gonna be static, so it's actually a-okay for that. Never mind, I lied. You can get back to your regularly scheduled whatever it was I was doing. We like to panic for no reason here on this channel. Alright, let's get ourselves another R3.5 or 3.25 here. And then we need to get a R3 or R1.5 actually, 1.5. 1.5. That should be 3 millimeters, and then the 3.25 should be 6.5. This doesn't look right. Oh, that's diameter. That's why. 3. See, that's what really annoys me about Fusion 360. What? 30? That's not why you typed 3. Is that it flips between radius and diameter all the time, so it gets you very confused. Maybe there's a way to fix that in the settings, but I don't know. But anyway, now we get a line. We're gonna give this 10 millimeters. That seems like a good value. That's 1 centimeter from the center of the thingy to wrap around. I need to feel this belt in real life. Here you can. Oh yeah. Same thing over here. What? Oh, yes. I guess I don't actually need that then. Actually, I can just extrude it to an object, and that's this object. Go. That will do it. Except, you know, this, we actually can go back to our sketch, and we can fix this, because it's actually lame and dumb. And just do this. And then that solves another one of our problems. This needs to be tangent to that. Now it's locked. And we go here, and we include these. There we go. And then I extrude these back about some number. Oh, how big it is. 5. 5 is fine. There we go. There's your belt channels. Now, because this might be sketchy, I'm gonna move that by up 1. That up 1. And then I'm also gonna fill it this and this. That much. Okay, I can just grab this one too. There we go. Wow, isn't that nice? How lovely. Wait, I didn't want to undo that. I just wanted to edit it. There we go. How lovely. Now on this end, I will have a pulley right here roughly, and that's there. Great. That's also where my end stop will be. This will click onto the end stop. Okay, great. Okay, now let's do this again. Or I just need to create a sketch here actually. And I just need to get some rectangles. Like that, and that. Boom. And there we go. Look at that. And then we add some fillets. These ones are gonna be less nice. 3. Then we add the last part, which is the screws that lock it in. Isolate. Okay, now I need to what is it sketching on? That's completely the wrong face. Oh, wait, no, that is the right face. Oh, got it. Great. Okay. We need to make some screw holes right about here. Dinner time? Yep, it's dinner time for me too. Ha 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 ha. Anyway, how long is this? That's 1 millimeter, right? Or 1, yeah, that's 10. Okay, and then this distance. Is, I don't know, like some value. Yeah, it's very helpful. What if we just actually did not sketch from there, but we sketched from here instead? Okay, and then I need to be able to section analysis so that I can actually see where I am sketching. Now we get ourselves one of these. Create a center diameter circle of 3 millimeters. And then I can do the same thing here. Wait, how long is this section? 3 millimeters. Is that right? So let's go here. Get ourselves 3 millimeters. I'll just write it. And then let me get another line from that section to here. And then I'll create a circle, 3 millimeters. And then I click finish sketch. And then I extrude both of these out. Go. That'll hold our belt. Okay. Great. That's fine. Okay, great. Great. I think it might be time to call this good enough. Yeah, I've been going for roughly 4.5 hours. We've hit a new longest stream, so that's cool. Let's see. Okay. So what now? We can unisolate this, I guess. Where did half of my everything go? Oh, this is good. I don't need to see body twirl. Alright, I think this part is basically done, except I need a place for the mounting of the whatchamacallit. I need a spot to mount the well, we need to add some screws so that it doesn't like disassemble itself. I can put a screw through there. Let's see. How large do we make these? How big is this screw that I have sitting on my desk? 20. Not that big. I believe I have some 35s around somewhere. How big is this? That's 30. You know what? How about we just make it long and then just like, it can just be whatever. There we go. Cool. So, how about that, huh? How about that? I think it looks fine. How far apart are these? 23. Do I have M5 by 20? I don't know. I have some M5s that I don't know how big they are. This is M3 by 24. I don't know. Here, let's see. It's 24, then that's good. M3 by 16. I'm M5 by 16. That's great. That's not big enough. What about this one? This one looks longer. I ordered an assortment of just like random M5s that I thought I would need, but I actually don't need any of them. This one is, oh, M5 by 20. Great. So how long is this? 23. That's less great. Okay, maybe I cut a like 5. You know what? It'll be fine. It'll be fine. These will go through all the way and just attach to the stepper motor, so that's fine. These screws hold these parts together. That's just where the belt goes. Yeah, this part looks good to me. All I need left is that spot for the belt holder. Yeah, the belt holder spot. So, what is this for again? I forgot. Oh yeah, that's for the vertical belt. So I can put the belt holder just anywhere really. The belt holder doesn't matter as much. Cool. Where does the belt holder go? I mean, not the belt, the badge holder. That's the word I'm looking for. The badge holder. Where does the badge holder go? You can go all the way off to the end, I guess, but that means that most of the weight will be at the end, so I'd rather not have that like that. Oop. We could put it over here. That'll probably be fine. That makes it less printable, so I don't want to do that. I mean, I could just like deal with it later. That's always a valid solution. I mean, I have enough mounting holes that I can just like attach it separately if I need to. Just rather not do that, you know? I mean, the reality is that most of the... What goes here again? Oh yeah. I can extend these up more. there. That'll help make it less weak and miserable. The problem is that much of the weight is in this direction, and all that it's mounted to is the single linear rail that goes here. So that's a very, very obvious failure point in the future. And this rail is pretty heavy, so like, then again, the rail is, I don't know. The rail is gonna be close-ish to the actual like point. The real thing I'm worried about is the 3D print failing, you know, which is a pretty common failure method I'd consider. So we can just expand this a little bit. And that'll help. And then let's just create some, you know what? No, we will not. We can save that for mounting holes in the future. So, yeah, I think this is fine. Nothing I can think about it. So I will print this, call it for today. I'll print this, and then we'll see how it turns out once it's done. Because this is where that linear rail is gonna go, or the carriage rather, and then the linear rail goes here. This is the screws for the belt. Yeah, okay. And that's another belt. Well, the belt pulleys rather. And then this is a stepper motor mount. This is where the only thing I'm missing is that belt holder. I mean, the badge holder. So, where should I put the badge holder? I can just put it in a random spot. But that's cringe. I can't put it here because that is where the belt goes. I need this badge holder to, you know what? What if I just, okay. Here's an idea. Actually, I can't go there, never mind. Idea canceled. Okay, here's another idea. We just don't deal with that for now. Because we have two belts. We have one belt that just goes straight through here. So that entire area is blocked. This part is for the linear rail, and that will be entirely blocked. This part is for the stepper motor, so that'll be blocked. Maybe above the stepper motor, it's fine. But, you know. I'll deal with that another day, I think. Unless... Here's what we can do. We'll deal with it later. No, I think I can put it... I think I can put it right here. This is where the channel could be. You know what? No, we'll deal with it another time. If I have to print it again, so be it. I don't care. That's okay. You know what? I'll make a single channel here just to see what happens. Because I can always just add that in like right there or something and then just like call it good. Yeah, like I can just add the slot in there and then it'll be fine. So let's just do that. What is that for? Those are the pulleys, right? Alright, let's get the measurements on this badge holder. Roughly 35. So it's 35 by I don't know, let's call that 1. That's fine. This is not as big of a deal. You know what? I'll deal with this. I'll deal with the belt holder another time. We're gonna call that for today. So, if we look at our checklist, what did we accomplish? We did not accomplish the badge holder. We didn't do a tubing channel. We didn't do a stiffer claw either. We didn't even do that. We did do this, I'd say. Actually, we didn't even do that either. We did something completely different. We started designing the gantry motion system for the robot. We got the grabber version 2 halfway done, with some of the improvements needed done, like the fixed hexagon, the better linear rail mounting position, the belt. But that's all we did today. Reckon we call it there. Thank you for watching. That end's messed up. Oh. There we go. So cool. Okay. Thank y'all for watching. I'll see you again very, very soon later. Yeah, I'll see y'all later. Toodaloo, etc. Bye-bye.